Hello everyone, and welcome to the first day of the Geological Society's virtual Careers Days. We created a unique programme for geology students that gives students the chance to hear from expert professionals working across different sectors in geoscience and in the UK. And I encourage you to ask them all the questions you can. Do sign into as many of the sessions as possible. It gives you a great opportunity to learn more about different areas, and it could help you consider a professional focus. This afternoon, we have sessions on geohazards, engineering geology, geodata risk management. Then after a break, we have a presentation on Chartership. Then finally, a very useful session on transferable skills and how they can help you stand out and be agile in your career. My name is Dr. Joel Gill. I'm on council, a trustee of the Geological Society, and currently hold the role of Secretary for Foreign and External Affairs. But it's not that long ago that I was in a similar position to many of you here today and had a really key moment at the equivalent Geoscience Careers event back in 2010. I completed my undergraduate degree in natural sciences at Cambridge. I'd spent some time working overseas in Tanzania and was in the middle of an MSc in engineering geology at Leeds, becoming increasingly passionate about the role of geoscience in international development, but unsure about how to take that forward in a career. At the careers event that I went to, there was a talk from the BGS, the British Geological Survey, a global geoscience organisation focused on public good science with government and research to understand earth and environmental processes. The talk by Fiona McAvoy described work that the Geological Survey had done in Afghanistan, and I had a follow-up conversation with Fiona about the range of international work that BGS were involved in. It wasn't just about the opportunity to work internationally that appealed, but also the approach that the BGS has, their passion for sustainable outcomes, meaningful partnerships, and ethical engagement. I knew at that point that I'd love to work at the British Geological Survey, and my day job now and since 2016 is as international development geoscientist at the BGS, where I divide my time between international development activities and research linked to geohazards and disaster risk reduction. My role's taken me to meet scientists in Zambia, work with government agencies in Guatemala, and advocate for the importance of geoscience at the United Nations. So do take time to ask questions, do reach out to speakers, do make the most of this brilliant opportunity, because you never know how it's going to help and support you in the years to come. And today isn't your only opportunity. I know there are events throughout this week giving you a great opportunity to learn more about different areas. And after this week, you may also wish to join the Society and be part of our work. Geological Society events and early career network, their regional groups around the UK and beyond are a great way to meet others and hear what it's like to work in different sectors and places around the world. You can review books for geoscientists, the Society's fellowship magazine, getting to keep a copy and gain writing, communication skills. And there are various committees that often have openings advertised that will give you experience and valuable skills linked to strategy, finance, business planning, charity governance. And you can add your voice to around 12,000 others to shape the future of our subject and champion its importance to society. The third hat that I wear alongside my BGS and Geological Society roles is leading a charity, Geology for Global Development, mobilising and equipping the geoscience community to support the UN Sustainable Development Goals. Over the last decade, I've spoken to hundreds of geoscience students around the UK and beyond, often about careers and how to build a career that links geoscience to different aspects of sustainable development. So before proceeding with the session, let me share some of my tips. And I think many of these relate to the theme and the themes being discussed today. So number one, geoscience matters. It's critical to progress towards sustainable development, but this isn't always recognised. And so we need to think about how we phrase our skills and our experiences and language that's more familiar to other sectors and professionals if we're applying for jobs within those outside of traditional geoscience employers. Secondly, is that geoscientists can contribute to a huge array of ways of helping to deliver the UN Sustainable Development Goals, both in traditional employers, but also in a wider set of organisations. And so one tip is to look at job descriptions on sites such as charity jobs or third sector organisations to identify the extra skills and knowledge that you'll need and can build throughout your career. I have a folder of dream jobs ranging from being involved in communications at the British Antarctic Survey to working on geoscience and international development in the Pacific Islands, small island states. And it's been really useful to look at what the skills are, what the level of knowledge I need to pursue those jobs in the future. The third tip is to read widely around development challenges, dip into other disciplines, look at key reports that come out of places like the World Bank, the United Nations, the World Economic Forum, and sector reports around things such as hazards or mining, in order to just understand some of the language that's being used and how our subject can connect it with other subjects in order to deliver development impact. Fourth is to network. Be proactive about building your network, engaging in your professional society, in international groups and forums. Look for things online. There are lots of different organisations running online events now and spaces where you can grow your network and ask questions and have a better understanding of what it's like to work in different places, as many of you are here to do. And then finally, invest in new skills and ways of working. So look for opportunities to develop skills that maybe you're not developing in your current courses around cross-cultural communication or some introductory social science techniques that may enrich your geoscience and your earth science. So I hope some of those reflections are useful, and you're going to hear lots more over today and in the next few days that will also give you lots to think about. A quick bit of housekeeping before we begin. During these sessions, your audio and video will be disabled. We encourage you to submit your questions to the panelists in the question and answer box. And as I said before, do make the most of these sessions, do engage with the speakers. Unfortunately, we won't be able to answer, we may not be able to answer all questions that are submitted, but we'll do our best. Before I hand the microphone over to our panelists, I would like to thank our speakers who volunteered time out of their days to take part, and also our generous platinum sponsors, Foodrow and the University of Edinburgh School of Geosciences for their support, their investment in helping students around the country and beyond understand how they can pursue a career in the geosciences. So without further ado, we'll head straight into the first session of the day on geohazards. And it's great timing because today is the UN International Day for Disaster Risk Reduction, and geoscience has a huge part in that. So it gives me great pleasure to welcome Irene Manzella, Ashlyn O'Kane, Harry Eady, and Isabel Taylor. And I'll hand over to Harry, who I think is leading this panel now.
Good morning. Just morning. So I am going to share my screen and start the presentation. We'll be talking about
it looks like we've lost Harry, everyone. Apologies for that. Julia, sorry, Aisling or Isabel, would you like to present first instead? Oh, you're muted, Irene.
Hi, Becky. If it is of any use, I can start.
Yeah, that would be great.
Okay, if you can hear me. Yeah. Okay, great. So hi everybody. I'm Irene Manzella. I will share my screen for a brief introduction of my career path and my my actual role. Can you all see my screen and the presentation in presentation mode?
We can see, yeah, looks great.
Okay, great. So, so as I was saying, I'm Dr. Irene Manzella. I'm Associate Professor in Engineering Geology and Geoscience at the University of Plymouth. And I'm also a Deputy Scientific Leader of the Geohazard, Geoengineering and Georesilience team of the Geological Society of London. After this talk, or if you want to contact me, here are some of my contacts. I have a Twitter, an Instagram, and a LinkedIn account if you want to connect with LinkedIn as well. So a little bit about me. So I started as my undergrad studies were in geotechnical and environmental engineering in Italy. So as you may have already noticed, I'm not British, so I come from Italy. And I then did my master thesis. So in Italy, the education system is different. So we have a 5-year degree that is composed by the bachelor and the master together. And so I did my master in Germany. So I started to travel when I did my master thesis, and I did it in this big laboratory that you can see here in the middle of the mountain in Germany. And then I worked in industry for a couple of years as a consultant, environmental and geotechnical engineer. And then I decided to go into academia, and I did a PhD in Lausanne, Switzerland, in civil engineer on experimental modeling of landslide, which I finished in 2008. And then I also had experience in volunteering and working for NGOs and disaster risk reduction and sustainable development in Nicaragua. And it was an amazing experience where I also started to use GIS. And also it was my first time on volcanoes and active volcanoes. So I started also to develop my passion for volcanoes as well. And so then I had some postdoc life, I would say. I did my first postdoc at MIT in the US, where I started to work with numerical modeling. And then I worked for several years in Geneva, where I started I continued to do experimental modeling, but not only in landslide, but also in volcanoes. I started to work with volcanoes as well, and numerical modeling. And I also started to teach engineering geology because of my background in engineering and working with geologists. I started to see that there was a kind of gap in the communication, and I started to see that I could kind of teach the main civil engineer principle to geologists to kind of fill that gap. And also I traveled a lot during those years. I spent months in Norway, visiting researchers in Norway, France, went to Chile, Argentina, Japan to see volcanoes. So I've seen amazing places, not only, and I also stay a lot in the lab and in front of a computer by doing the numerical modeling. Then I moved to the UK and now I am, after some years as a lecturer, I'm now associate professor. And also here I could even further develop my teaching skills and my teaching portfolio. And also I've been a lot in the field. As you can see here, I'm in Lime Ridge, looking at amazing landslide in the UK. And here I'm in Turkey looking at earthquake as well. So I've added that geohazard as well during my years here in Plymouth. So I'm working also now in multiple and complex hazards. And I've been a lot in the field also as well here in Etna, Vulcano, and around the world. And here you can see me in Plymouth as well for our graduation ceremonies. Then there was also something in my career path that it was not planned for all of us, and is the 2020 and 2021 lockdown life. And I took this opportunity and tried to see this as as an opportunity to develop new skills like planning skills and managing stress, and I have to deal with difficult situation and new demanding co-workers. And I have to say that I've developed a lot of new skills, and I refine a lot of skills like multitasking, flexibility, solving complex problems, having multiple roles at the same time, and deal with severe disruption during my work time. And then after this couple of years, I'm also aiming to something new in the future. So I will be, from the 1st of November, I will be Associate Professor in Geotechnical Engineering and Geohazard, and coordinator of a new center in disaster resilience at the ITC, University of Twente in the Netherlands, where the launch will be the 28th of October. If you want to follow it, it will be streamed online. And I found these quotes that really kind of fits with my new steps in life and my careers, also because it involves windmills, which fits nicely with the Netherlands, and is something that I always try to apply in my life and my career. And all the obstacles that I found in my career is that when the wind blows, the winds of change blow, I try to build windmills instead of walls, and take the opportunity to improve and grow. And so for that, we need you, whether you like geology, chemistry, geography, or math. The geoscience community really needs the new generation to create a more resilient and multidisciplinary geoscientist. And so thank you for your attention, and I'm open to have any question from you. And if you want to contact me, I'm happy to be contacted too. Thank you.
Thanks, Irene. Harry should be back now. So I think Harry's going to present next, if that's okay.
Yep. Apologies about earlier. The internet decided to disappear just as I was about to present, but I'm just going to share my screen. Okay, so see, my name's Harry. I'm an engineering geologist, and I work at Fugro within the geoconsultancy business line. I have a master's degree from the University of Southampton, where I studied geology between 2013 and 2017. Just going to quickly talk about my career path from how I got from University of Southampton to where I am now. So in 2013, I did geology, MSci, so the integrated masters. And I left in 2017 into a job with Fugro in the land consultancy team, where I worked for 2 years and joined the marine consultancy. So I currently work as an engineering geologist within the engineering geology and geohazards team, with a focus on supporting global, current and future large-scale offshore developments globally. So there's a couple of photos, like a highlight reel almost, from me being in the rain in Bulgaria whilst doing mapping, to going on and doing field work on land, to organising CPT, site investigations, integrating geotechnical data, presenting at conferences, and working offshore. So to talk about my current role. Current role is to assess offshore geohazards for their implications to future development. I'm sure you've studied geohazards before at university, but they can be simply described as any geological or natural process that can negatively affect infrastructure and pose a risk to human life. These can be constant or sporadic, fast or slow, and large or small. In the context of a wind turbine development, we could have microbial erosion of that turbine would be constant, slow, and on a small scale, where a landslide could be quite the opposite. And obviously all of these hazards are assessed in terms of their consequence and likelihood, very much similar to a risk assessment that you would do for any practical aspect of your careers. Just some examples here of what we're looking for in an offshore realm. It can be anything from landslides, turbidites, pockmarks, volcanoes, anything you can think of, we have to take into account. To look at this and to help support the infrastructure development globally in the offshore area, the work as an engineering geologist in this field includes consultancy-led generation of 2D and 3D ground models, analysis and real-time support of marine site investigations, core logging and microscopy, foundation appraisal for structures, and working offshore on drilling vessels, which is often up to 6 weeks at a time, doing 12-hour shifts every day, either from midday to midnight or midnight to midday. Just did a quick thought, and I believe that during my time as an engineering geologist, I've supported the infrastructure development in 30 countries, as seen on this map. So get the opportunity to work in a load of environments all the way around the world. I can't provide any specific project examples due to client confidentiality. However, I will provide a typical project workflow, such as what you can see at the moment. So first we start off in the desk study phase, which is where you can assess what data exists on a site. So bear in mind, this is all going to be, for example, for a wind farm. If a client would like to build a wind farm, they need to know what the site looks like before they build it and before they go and acquire data, because it's all very expensive and takes a lot of planning. But we don't have the benefit of having geophysical, geotechnical, GIS or engineering data. So we have to go about using public data, which could be British Geological Survey, or it could be academic reports or any experience that Figaro have working in that environment, which we use all of that to build up our conceptual site model, which you can see on the top right hand side, but it still means our image of the site is pretty blurry. Moving on through, we then do a geophysical survey, which is something that you'll get the opportunity to work on, where we go and use big vessels or underwater AUVs or remote controlled robots to go and analyze the seabed and shallow subsurface conditions, which basically provides us an image of what's going on. So we can start to identify those geohazards. In the top right, you have a piece of bathymetry, which is very much like aerial mapping, but underwater. And on the bottom, we have a seismic profile, as I'm sure you've probably seen at university. But we need to assess these so we can start to identify what hazards might be present and what challenges might be there. But this starts to build up our idea of the site, because we can start having an idea of what geohazards might be present. Then we get to go and do the geotechnical survey, which is using that geophysics information to assess what we might find. That's where you get the chance to work offshore, doing sampling, or if you're more onshore based, you get to use different drilling methods on land, as you can see in the middle there. But you'll be logging soils offshore, you'll be integrating that data and trying to assess what hazards are present and what geological units are present. And then we build that all together in a 3D environment, often GIS, so we can do an assessment of what that actually means in extent for the site. So in these images here, we have a slope stability assessment for a cable route, or we have an engineering assessment for foundations for the wind farm. Building all those data sets together gives you your final ground model, which is what we deliver to the client as the integrated package. And it's what they pay for, so they can understand the conditions on their site and safely develop, in this instance, a wind farm. But in terms of marine infrastructure, it could be oil and gas platforms, pipelines, or cable routes as well. Just as a quick note, these are the type of skills that I believe I've developed during my time at Figaro and working in this industry. You certainly become more communicative, being on client calls, report writing, and presentations. You become analytical because you get to view and interpret seismic data, borehole data, geological mapping, and GIS. You become practical because you're looking at microscopy, site work, and core logging. And you become flexible because you are working offshore, you get to work on land in the office, and you have to balance the different projects at different times. So that's all I have to say. If you still have any questions, please stay connected. You can contact me on LinkedIn. My profile is just there. Or if you want to chat about recruitment opportunities, you can talk to Liz Sumner, and her details are there. We'll all be at the Gather Town as well, so you can ask any individual questions to myself, and I'm free to have a chat whenever you'd like. For any further information, you can have a look at this dedicated careers page or scan this QR code. That's all I have, so thank you very much for listening. So I'll hand back to Becky.
Hi, brilliant. Thank you, Harry. Ashleen, would you like to present next?
Okay. Can you see that okay?
I can, brilliant. Thank you.
Perfect. Hi, everyone. I'm Aisling, and I'm a final year PhD student at the University of Cambridge. I'm in the field of active tectonics, so all our sciences here. What I particularly do is look at the role that the continents play in controlling earthquake hazards, faults, and the mountains along major sort of the Himalayas, the Caucasus, southern Peru. Some of the places that I've got to work are in the Himalayan foothills, shown up here. More increasingly, I'm working in more urbanized cities, such as Cusco in Peru, because more people are moving from the mountains to the valleys, which has better job prospects, flatter land, availability to water, etc. But then sometimes you get to go to really remote places like the high altiplano in Peru and the Angren Valley, shown here in Uzbekistan. So I thought what might be useful for someone who's interested in doing a PhD is to know what I do on a day-to-day basis. And the real answer is actually it varies quite a bit. But the things that I do often comprise of 4 key areas. And the first one is earthquake seismology. So this is just when I look at the earthquakes in detail and their characteristics. So I look at the individual waveforms from a particular earthquake or their distribution across the continents. And this is usually quite informative because you find that they tend to occur along the edges of mountain belts where rapidly urbanized areas are. So that's obviously poses a hazard to people who live there. The second technique that I use is structural geology. And this is where we go out into the field and we look at the rock and how it deforms, whether it's by faulting or folding or taking dips of bedding planes, which are shown here. And then you collate it and it can tell you something about the structure. Another technique is to look at the tectonic geomorphology. And this is where we look at landforms such as rivers and terraces, essentially the deformation on the surface of the earth. And that can tell us how tectonic processes are creating these landforms, essentially. And here we can see a very small terrace, and this is in the Himalayan foothills. And here what we can do is sample these. So we put essentially a tube into the sediment to collect a sample, and that can tell us the date of when those sediments were laid down. So that can give us ages and how much has deformed since then. And the last thing I do, and predominantly I do this the most, is computational work. And often in areas where there's lack of instrumentation or observations, we like to make models just as Harry has shown, essentially to fill in the gaps, the data gaps. And what I did here is I made a pretty simplified generic foreland basin model based on what a foreland, essentially range front foreland, would be if I simulated an earthquake, which is this red line here, into the Himalayan foothills. So here we have the Ganges basin, here we have Tibet, and what we can do with this information is it can simulate what an earthquake would be if it were to happen. And that gives us an estimates of particular ground motions or likelihood of certain frequencies. I've tried to put a quick pie chart together just to show you the range of things that I do in my role as a PhD student. It's largely reading literature, analysing results and writing papers, but you get to do a lot of other things like attending seminars, conferences, some outreach activities, undergraduate teaching, and working collaboratively on other research projects. And yeah, just a caveat to say that this is just what I find in my PhD. What you will find is that every PhD project is unique, and it will have different amounts of activities and expectations. So one of my projects that I did in my time as a PhD student is to look at the ground checking from earthquakes in these rangefront locations. So all these focal mechanisms, which is just the coloured circles, are all past earthquakes, and this is in Central Asia and India here. What you can find is that these earthquakes line the edges of these mountain belts right next to these basins here. So this is the Ganges Basin, this is Tarim Basin, and this is a problem for 3 reasons. The first is that these basins are rapidly urbanizing, and even megacities like Delhi now are located in them. The second is that these areas have a large range of earthquakes, and they have a long history of them, which poses hazard to the people who live there. And the last one is that the basin's sediments that they're made up of, so all the cities are built on, are known to amplify earthquakes and the ground motion. So one example is the 2005 magnitude 7 earthquake in Pakistan, which is just up here. And this was the Balkot Valley before the earthquake, and this was after. So you can see that just one of these earthquakes caused huge rate of destruction, and why it's important that we learn better about how the earthquake behaves, the processes that go into amplifying the sediments, and talk with engineers to put in place measures to mitigate the seismic hazard. This is just an opportunity to show you what other things I get involved in on the freedom you have, I suppose, in a PhD. The first is same as Harry, you can go and present at seminars or conferences. You can demonstrate in undergraduate field trip, which I highly recommend because it's got all the fun of the field trip and none of the work, I would say. You can get involved in real-time projects. So this was a earthquake response mission that was run by EFIT that I got involved in last year. It brought together academics, industry, and policymakers to do a rapid assessment of the damage caused by the earthquake. Also, you can take training courses. There's loads available to students in full-time education. One that I'd recommend is coding courses that Code First Girls run. They're fantastic ambassadors for coding, and their courses are all free. They give loads of support, and they're really great. You can get involved in policy working groups, and also in my PhD I work with industry, but there's loads of opportunities to work with industry in policy, 3-month internships, things like that. And lastly, I would say, get involved with all these types of outreach events, because the more people collaborate, then the more growth of knowledge and dissemination there is amongst the different working groups. So how did I get here? Again, I did geology with physical geography with Harry at Southampton, and one of the key highlights for me was, again, the 5-week mountain project in Bulgaria. But during those 3 years, I developed skills in writing, computer software, and most importantly, interpreting geological and geophysical data sets. Where I went next was actually, I went into industry for 2 years. And I was an engineering geologist in Northern Ireland, and I did ground and overwater investigations for things like wind farms, proposed housing developments, bridges, roads even, like the A14. And what I would say is most people have a plan in their head for their career, and they think that's what will happen, but actually that's what it looks like. As Irene said, life will throw things at you. You have to adapt, and as long as you're interested in something, reach out to the people that you want to, in the field that you want to go into, and they'll help you get there. So it doesn't really matter about your background or Everyone's career path is different. So do feel free to get in touch if you're interested in pursuing a PhD, postdoc, or just what academia is like. If you're trying to balance, would you prefer academia or industry? Thank you.
Thanks, Aisling. That was great. So I have Isabel next. I can see Isabel's here. So Isabel, are you ready to go?
Yes, hopefully you'll be able to see my screen in a second.
I can see your screen.
Can you see the presenter view or the other one?
Yeah, I can see full screen now. You're good to go.
Okay. So hi everyone, my name's Isabel and I am a postdoctoral researcher at the University of Oxford. In case any of you are unfamiliar with what a postdoc is, this is usually a research job, mostly based at a university, and it's what a lot of people do after they finish their PhD. And sometimes people do one or more postdocs before they move on in an academic career. So obviously everyone's experience of their postdoc and PhD is very unique, but I found that my postdoc has really built on my PhD research and helped me develop my skills even further, while also giving me more responsibility. So now I'm part of a number of different projects which have deliverables, and I'm also responsible for supervising several students. So I wanted to start by just giving you an idea of what my research is about. So I use satellite remote sensing to study volcanic plumes of ash and gas from volcanoes. And we do this for a number of reasons. So perhaps first and foremost is that the hazard that these plumes present both to people who live near the volcano is very dangerous to people's health, and also further afield to the potential hazard that these plumes present to aviation. And we're also interested in the impacts that these plumes have on the environment and climate. And by making measurements of volcanic gases, we can sometimes infer something about what's happening within the volcano, which is very interesting and potentially useful when we're thinking about volcanic hazards. And so my job is quite varied. It's got perhaps three main parts. The first is that I am working on developing and improving methods for detecting and quantifying information about these plumes, and I work with a specific satellite instrument. And then the next part is generating data sets from the methods that we're using. These data sets are things that I use, but also we pass to collaborators. And then finally, it's exploring these data sets to answer science questions. So that might have a volcanology focus, or it might be looking at the atmospheric impacts of these plumes. So I'll give you an idea of the day-to-day activities. My job is primarily office-based. I spend a lot of time on my computer, and I say the majority of that time is spent doing programming. Now, this is something I actually really enjoy, and it's perhaps one of the skills which I'm most grateful that I learned in the last 10 years, partly because it's essential for my job, but also because it's a very transferable skill, which is very useful in other fields and also in other careers. I also spend a lot of time supervising students, working with different people on different projects, turning my results into papers and presenting these results at various meetings. And so I really enjoy my job. I think that's in part because it's really interesting, answering some really interesting science questions, but also because it's quite challenging. It means I'm always learning more about my field and developing my skills. I'm definitely in an environment which really encourages this continuous learning and skill development. And I think also because the work is very varied. So I'm working on several different projects. Some of these I'm providing data for other people. I'm working with very interesting people. And then I also have a fair amount of time to work on my own interests and to choose the direction that I want to go in and explore the questions that I'm interested in. I'm working with lots of interesting people, doing lots of interesting things, both in the UK and abroad. And in general, there are lots of opportunities to travel, even though I don't do any fieldwork myself. Obviously, in the last year and a half, that's been pretty minimal, but usually there's lots of conferences to go to. And some of these are held in very interesting locations with a volcano to go and look at. So how did I get here? I perhaps have a very traditional academic career. I did my undergraduate degree, which was in geography, then did a master's degree in volcanology at Bristol. And I think it was during my master's degree that I first got a real idea of what it was like to do research, which was through my master's project, which was looking at volcanic ash with satellite instruments. This is the first sort of opportunity to explore research as a career, and I realized that I really enjoyed it, as well as in really enjoying that field. And that's what made me decide to go on and do a PhD. I did, however, have a year's break between my master's and my PhD, perhaps not of my own choosing. It was because I'd applied to a few schemes and didn't get to take on any of those opportunities. So I took a year out, during which part of that time was just spent, working and earning money. But I also took 3 months where I volunteered at the Hawaiian Volcano Observatory in the US, which was a fantastic opportunity to live and work on an active volcano and get an idea of some of the difficulties of working in an operational setting. And it really sort of highlighted to me why we bother making these measurements, and made me want to continue working in volcanology. I also did a summer project at the University of Oxford, which was just before my PhD. Again, it's a really good opportunity to just make sure that you really enjoy doing research. And I recommend looking out for these projects as well, because they're often paid opportunities to try out research. And then I went on to do my PhD at the University of Oxford. I was part of a doctoral training partnership, which actually allowed me to choose what I wanted to do in my research, which was a really amazing opportunity. And technically my PhD was in earth sciences, but I actually spent all my time working in the atmospheric, oceanic and planetary physics department. And again, that was a really nice opportunity. It's a very multidisciplinary environment, working between different departments. And my kind of goal of my PhD was to be using the methods developed in physics and applying them to answer questions in volcanology. So it's nice to work between these different groups. And then I was very lucky at the end of my PhD that a postdoc position opened up in the group I'd been working in, and I was able to continue my research after that. And yeah, I highly recommend exploring opportunities outside of your subject area and your department, as you often have skills which are really valuable to other areas. And we'll finish there, and hope I can answer any questions later.
Thanks, Isabel. That's great. So I can see that we've already got some questions in the Q&A box. So I don't know whether you'd like to rotate the questions around yourselves. So Harry, would you like to kick off? I think there was a question for you in the Q&A box.
Yeah, sure. So the question was, how did I go about landing my first job at Fugro, and do I have any recommendation for those seeking to join the industry? I joined Fugro from an assessment day that was ran over 3 days, and we interviewed about 15 to 20 candidates, all for graduate positions, come straight from university like myself. That's probably quite typical in the industry, where there is a lot of positions generally going, and we do have quite an active job market in engineering geology and in that sort of industry, because there's projects happening across the UK and across the world all the time, which need graduates, and they need engineers happy to go on site, happy to look at the data. So there's a lot of opportunities for those kind of interviews. It typically is an assessment kind of interview process, where you have a sit-down interview, and you will also have a quick maths assessment and maybe a practical aspect. I remember in my Fugro interview I had a mapping exercise, and for my current role which was an internal move within Fugro, but that also included a practical assessment as well. So that's what I would recommend, and that's how I I got into the industry. In terms of recommendations for those seeking to join, I think it's getting as much experience as you can, even just reading around different papers. And if you want to work in the UK, have a look about London soils and just soils of the UK. I think anything you can talk about in an interview is really useful. So I think that would be my response to that one. I see there's a question about remote sensing. No, I think Isabel would probably best place to answer that question. So how much do you see a future for people who are looking at that field?
Sorry, I'm just trying to find the question. Oh, there's the question box. So I think remote sensing is a really fascinating area. There's a huge amount of direction, and so much of geoscience uses remote sensing now. I don't think it's necessarily something that's covered so much on undergraduate courses. There might be modules or a couple of modules which focus on them, but it's really something that you can learn after doing your undergraduate degree, to take it further, either on an actual job or as part of a research project.
So just to add to that as well, I know a lot of the work we do on land and marine relies on remote sensing as well. All of the advances in underwater robotics and actual automated drone surveys of land and marine environments is all related to that kind of research. So there's definitely a big future there.
Hi, so, and if I can ask the question about PhD work and funding for PhD. I mean, it's there are a lot of so the different source for PhD funding. That could be from the UKRI. There are some PhD programs that are organized by other funding bodies, like it could be some projects that have been funded particularly for one researcher in the university, but also there are PhD who are funded by the university themselves. And for example, I can talk for the University of Plymouth. We have regularly PhD that are funded for every year for our school, and then there are funding from some doctoral training programs that are made in collaboration with other university like the UEA or other university. So we have regular calls for PhD at different time of the year. We normally have PhD starting the 1st of October and the 1st of April. And yeah, it's there are also different websites that you can find PhD calls and advert, but also looking at different professor or lecturer that or project that you like, and see if there is any possibility opening in that group. Is also a possibility contacting the person that you are you think that they are working in something that you are interested in, and also there is possibility to build your own project sometimes if you are really passionate about something, and so you can also discussing with the people that you're interested in that you are passionate about a PhD. And so there are many ways. So if you are interested in that, I really strongly encourage you to look at the group and the university are working in the subject that you're interested in, and looking at and contacting the people, or looking if there is any call open in that group.
I can answer a couple of questions that have come through about industry. I'll start with the first one, which anyone can chime in as well. But the question was, if one is going to industry, would it be better to do a MSci or a BSc and an MSc, or is it treated equally? I think that really depends on which site of industry you're going to go into in terms of engineering geology and infrastructure development within the UK, depending on the job that you go into. As an engineering geologist, I think an MSci is more than capable, provided it demonstrates the correct skills. But I know, for example, if you wanted to go into petroleum engineering, then obviously there's dedicated masters, which might be more beneficial towards that career path. And in some aspects as well, geotechnical engineering or the more engineering heavy courses, I don't believe the MSci covers the actual pathway that might be needed there. However, in industry, there's a lot of chance to learn on the job, and you get a lot of training within industry. So it's not something that would exclude you from that in the first place. In terms of which GIS softwares are used in industry, we typically use ArcGIS. I think that's taught in universities and is commonly available as well. That's our main one, but we also use 3D modeling software as well, depending on the project need. That's usually the type of Leapfrog and software such as that. So does anyone else have anything to add on to that, those two?
I can answer the one about looking for short research projects, if that's helpful. In terms of, I think Philip asked it, how to find out about short research projects like the summer one at Oxford. The first thing I would say is, and slightly touches on what Irene said, is if you have an idea of the type of research that you would like to do in those summer projects, there's usually a few institutions that will lend itself to that particular research field. There'll be multiple universities that do volcanology, hazards, earthquakes, whatever that you're interested in. But if there's a certain discipline within that, then they'll usually be splintered off. A good resource to find information about these sorts of things is like the GeoSoc website. There's the UK Centre for Observation and Modelling of Earthquakes, Volcanoes and Tectonics, and they often, on their news section, put all the available summer internships, PhDs, postdocs, any sort of projects that are available on there, and that's UK wide, so that's a good resource that you could look into. And then I think there was another question to do with what should I study in a master's to get into the field of volcanology. Again, I'd say a master's could be beneficial, but it's not always necessary. So if you know already you want to go into volcanology, it's more a matter of being keen, willing to learn, wanting to brush up on where's volcanology at the minute, what can we do with it? And I think as long as you're super enthusiastic and want to learn, I would get in touch with departments, because I myself went straight BSc to PhD. I know people that did both, but it's really what stage you're at and ready to do independent research, or you would like that extra year for that foundation.
I think I can add to that question as well. There are specific volcanology masters that you can do, but it's definitely not necessary to do that if you have an opportunity, if you're doing a 4-year undergraduate degree. And with volcanology, it is massively multidisciplinary. So there are people from physics, from geography, earth sciences, and many more subjects as well. So any background is great because you'll bring different skills in. If you can, and if you're really keen to continue in volcanology, I think what is really helpful is if you have the opportunity to do a 4th-year project or any kind of dissertation in a related area, just helps you to sort of learn a bit more about the topic. But even if you do a dissertation in something else, again, you're learning valuable skills, which would be helpful if you went on to do a PhD.
There's a couple of questions about graduate engineering roles. I'm going to give a really broad answer here, but in the Gathertown networking session tomorrow, you can speak to a recruitment manager from Fugro. You don't need to speak to her necessarily about things Fugro related. She will happily answer questions about that kind of process, recruitment process into industry. I think that's the best person to ask, because I can't comment on recruitment opportunities, or as there's a question about someone being eligible to work in the UK. Again, that's something that the Liz Sumner will be able to answer in a lot. She'll have a lot more knowledge of that process.
Thanks, Harry. I've got a specific question here for Isabel, and it says, as someone currently applying to Bristol's MSc Volcanology 2022 programme, what was the research culture like in Volcanology research group, and how did it inspire and inform your future career plans towards your PhD?
So I will say that it was a while ago since I did my master's at Bristol, so I imagine the course may have changed. It's a great department with a lot of interesting research, and the course was really good, if challenging, although I imagine all masters are challenging. I think the best thing I got out of it was my master's project, which for me was in satellite remote sensing, and just really highlighted that I was interested in that, and was something I wanted to do. And there was a lot invested by my supervisors in helping me complete the project. And so it was a good course, but yeah, it was a while ago, so it may have changed. I'm sure it's still good, but the content may have changed.
Thanks, Isabel. That's great. So one question that I'd like to throw out to all of you, and it's kind of slightly difficult question maybe, but I think it's very important. So Isaac asks, how important would you say having a master's or other postgraduate qualification is when looking for a job in engineering and in the geohazards industry? It's the age-old question of, is kind of an undergraduate degree enough, or do you recommend pursuing postgrad study? So I don't know who wants to go first. Maybe Irene? I'll pick on you. You're muted.
Okay, so the I don't know how to. So there are different paths. So I have a really particular career path. So I've been kind of arriving to the geoscience a bit by hazard. So I was more and also I'm Italian, so it's a bit difficult for me to answer this question because I have a different background in the sense that the education system is different in Italy, and also the work marketing is a bit different. But I can say that if you are, if you show passion about what you're doing, and if you have kind of interested in different things, so you can make your way, and also there is not I would say only one way possible, and also there is not a straight line as we were saying before. So in a way you also have the possibility to try something, and then if you don't like it, also to change the path. For sure, it's not compulsory to do a master, or there's not again, there is not only one way system. So you can choose to be to try and work for after your bachelor, and then decide to do a master afterwards, and also the reverse, doing a master and then trying to go into industry afterwards. So yeah, I don't know if I've answered the question, but I would say that you can do yeah, you can follow different pathway, but then, and you can also find your passion afterwards. So you can also find your passion in a later moment in life. So you really don't. What I can advise is just to follow what you really like, and then there would be a way to arrive there in some way.
Thanks. So Ashley, I can see you've got your hand up.
Yeah, I just had a point on that maybe not everyone's aware of. A lot of industry companies will now support you to do a master's. So even if you're set on you really want to do a master's and you want to do a project, which, you know, as some people here have done, and it could be a really good experience for you, it's not always necessary to do it before you go into work. A lot of companies will, they do have programs where you can work 4 days a week, and they part fund your master's or stuff like that. So that's something to be aware of too, just because, you know, not everyone has 10 grand lying around, and you know, if you could work and do it and get your qualifications at the same time, then it's something to be considered.
That's a really good point, and it is so expensive to pursue kind of further education. So thank you for bringing that up. Harry, you did say that you had postgrad study as well as undergraduate, didn't you?
Yeah. I personally, I've got an integrated master's, so it's not strictly postgraduate. But I think the benefit of that additional the year there was that I could really refine the bits I was interested in. So my 4th year was in marine geology, which helps in the day-to-day job of being a marine engineering geologist. But I don't think it's strictly necessary to have one to get into industry. I think if you're willing to, as a lot of people have done, you can go straight as a graduate role, work on sites, work on actual in the field industry. I think it's a very open market, and I think it's just the willingness to be flexible and willingness to learn. Companies will teach you up to their standard or the British standard of UK geological work. So in that regards, I think you can get into industry pretty relaxed. I think also the companies will train you and show you all the different areas of things which you might become interested in. And like Aisling said, you might develop your interest from industry into a certain area which you could go on to do further study. So I think it really just depends on how flexible and willing you are to try different things.
Great, thanks, Harry. Does anyone else have any thoughts on this that they would like to put forward? We've got lots of questions to get through, and I'm afraid we're not going to get through them all. Sorry.
No, just one quick point is that adding to what Ashley was saying is that, and Harry, is that most of, like for example, most of our master here, they offer part-time possibility, so that combines really well with the also with the possibility from the employer to support you in the master, but also even if they don't support you, you could negotiate to do a master while working and, you know, supporting the master with the salary that you have by doing the part-time route. It is also another possibility.
Thanks. That's true as well. I've got another question for Isabel. Which programming languages do you use the most? Did you cover this?
No, so I use a language called IDL, which is not very widely used, but it has been used a lot in Earth observation. I'm primarily using it because a lot of our legacy code is in this language, so it's kind of hard to move away. If I was going to recommend learning a language, I'd say to learn Python, as this is free. There's loads of courses available online, and it's becoming very widely used in geoscience and environmental science. But I found that moving between languages is not too challenging once you get used to different syntaxes. So I think once you've learned one, you know, you've got a really good skill to work with. But yes, Python would be my suggestion of something to learn.
Great. No, that's very useful. So thanks. So another question that I'd say we can throw at you all, for undergraduates who are still deciding on what specialization to pursue, how do you have any suggestions, tips on what specializations are in demand right now and what would be good to take? I think we could have a whole hour session discussing this. Got 10 minutes left, so I'll start with Irene. Pick on you again. So what areas kind of would you say geohazards or geoscience in general would you say are in demand right now?
I think that for now, because we are facing very complex geohazard and you know, my last slide, it was about that. You know, I think that whether you like any of the discipline that you like, and you know, if you are more into math or geochemistry or geology or geomorphology, is like there is really a need to an interdisciplinary approach to geohazards. So what I really think, I'm a really passionate advocate of following your really your passion, because then at the end you will find a way to work in what you really like. But in terms of industry, I have to say that most of our graduates, they found work in engineering geology, so in geotechnical engineer company or engineering geology company, and they a lot of time they end up working in geohazard, especially, you know, for landslide assessment or depending on which part of the world, you can also work in volcanology and an earthquake. But yeah, in the UK, you will find a lot of an engineering geology company. They work in slope stability, and they work in geohazard in that sense, as Harry also was showing. And but again, I really think that finding you know, looking for studies or postgraduate studies or even undergraduate studies based on the market is a bit tricky, because then if you don't like what you're doing, then it's difficult then to you know, to bring it to success. So just follow what your interested are, and even if you think that maybe there are a lot of skills also that you can develop in the future, and you can develop during different type of master program or postgraduate program. So yeah, I know that it's a very vague answer, but yes, that there is really the need of this interdisciplinary and common effort for facing this complex geohazard. So I really encourage you to follow your dream. As I know that it might feel cheeky, but it's what I think is the best advice that I can give, based on my experience as well.
Thank you, Irene. Aisling, what would you say your thoughts are on in-demand kind of areas within geohazards and geoscience?
Yeah, so I would say the main thing is to be open to interdisciplinary work. So my PhD was actually supposed to be straight earthquake science. And because of my industry background, I now, ARP got on board, and I now work with them to come up with earthquake resilient infrastructure in the areas that I do the earthquake science. So it's a lot of academia is unpredictable. So you'll find something interesting and then you'll go down a path. But I think at the minute, there's a big push for sustainability. So certain sectors of geoscience, you know, we're trying to move away from, we're trying to move more into like the green sector, for example. we're trying to think more sustainably about how we do our research and what questions we're asking, rather than just saying, oh, I would love to go to this place like the Himalayas to do earthquake science because it's a laboratory for active tectonics. We have to think about, well, let's set up long-standing relationships with people there, and actually it's more useful for us to do workshops there and train masons and sort of communicate what we know about the science to there, so it kind of then the communities know what's going on and they look after it themselves, rather than us going in, taking some information and leaving. It's not a very good approach. So I think the geohazards is definitely changing, and I'd say in the last like five years it's changed a lot in how we approach our scientific problems, but mainly sustainability, and particularly in what Irene does, where we actually have to think about the resilience side of it. We can't just study these hazards to people and then do nothing with that information. So working with engineers, policymakers, communities to make essentially areas more resilient is what I think.
Great, thank you, Aisling. So we've got kind of 3 minutes left. So I'm going to ask Harry if you've got a quick answer for a minute, and then I'll ask Isabel.
Yeah, my quick answer would be joining a company such as the one I work for, but there's many in the UK, many around the world. The graduates are often not subject to, but you're welcome to join a larger graduate program when you join, which will get you experiencing all different aspects of the wider job role. So that could be geophysics, that could be geotechnical, it could be core logging, it could be anything you can think of, lab work. And I think because of that, they are willing to have flexible staff members who are just willing to learn. And I think then you would find what you are interested in, which you can continue. But I think definitely there's scope just to get involved and find something that you enjoy within the industry, certainly.
Thanks, Harry. Isabel, have you got a fast answer?
I think, try as much as you can. And if you have to choose, just choose something you'll enjoy, because it's going to make it a lot easier to study and be engaged in it. And otherwise, think about the skills you might get out of it, whether it's lab skills or coding skills or maths, and what you think is valuable in a future career.
Super. Well, thank you ever so much to everyone. That was a great first session to kick off the first day. There's some questions in the Q&A that we haven't been able to get to. A few of you might be able to type answers back if you've got time. And I know that you've passed on your details at presentations. So if there's anything critical, please drop the speakers a line. The next session that we have is completely different. It's engineering geology, ground investigation and geotechnical. On this panel, we have Julia Hill, Katrina McDonald, Richard Luca and Wesley Dixon. So thank you all very much. So we'll move on to engineering geology now. So Julia will be presenting first. So are you ready to take it away, Julia?
Yeah, thanks, Becca. So I'll just share my screen. Sorry, I'm having a slight issue.
No worries. I can see it now.
Right, sorry about that.
Okay.
It's always typical when you're live. Right, So afternoon, everyone. The intention for my particular presentation is to tell you a little bit about myself and my current role and my role within the industry and how I got there. So my name is Julia Hill and my role is as a geotechnical engineer at Roger Bullivants. And outside of my day job, but it does take up a proportion of my time, is I am the current chair of the Federation of Piling Specialists Early Career Group. So what the FPS is an active federation of geotechnical consultants and contractors that are dedicated to improving standards, safety, working conditions and commercial practices within the industry. And if you were to get into the sector that I work in, I'm sure you'll hear of us. So in terms of a little bit of background and how I got into my current role, I started with Roger Bullivants in 2015. And this was following an integrated master's in geology from the University of Liverpool. So a little bit similar to Harry's master's from Fugro. And then once I'd got into my role, I started as an assistant geotechnical engineer and then within a year promoted to geotechnical engineer. And I found that I was understanding my role and was learning on the job, but in order to become a chartered engineer, which is the path that I was looking to follow, I carried out an academic assessment through the ICE, which is the Institute of Civil Engineers, and found that in order to meet the requirements to be considered a geotechnical engineer, I would have to go back to university. So this is touching upon what we were discussing before with regards to going back to university after being in a role. So I went back to University of Birmingham and did an MSc in geotechnical engineering part-time. So that was over 3 years and actually finished that last year. And within the industry that I'm in and my role, I'm very much still classed as within my early career. I have 6.5 years experience within Roger Bullivant, and it has solely been with Roger Bullivant because within my role I've been afforded numerous opportunities to learn and develop, and I'm very happy in doing what I'm doing. So I think in general it's really important to understand what a geotechnical engineer does. And what I've done here is taken the definition of GeoConstruct, which is a construction-based platform. So a geotechnical engineer is a geotechnical engineer that has an important job role in analysing soil, rock, groundwater and other earth minerals prior to construction projects. This analysis can help determine what materials must be used in the structure's foundation or overall design, or whether the project needs additional measures to ensure it is safe. So based on this definition and from my experience within the industry, a geotechnical engineer role is a pretty fluid one because you could be responsible for various aspects of a project. So you could be looking at specifying the site investigation. So that could be like your phase 1s and your phase 2s, so a desk study and a ground investigation. But then that also could be designing and implementing the foundations for a particular project. Or you could be carrying out all three, and this depends if you're working for a contractor or a consultant, and that's something that you potentially want to consider when you come into the end of your degrees. So in terms of my role, I work for a piling contractor. So that is a piling foundations contractor where we design and install either driven piles, cast in situ piles, but also carry out ground improvement techniques for various structures. And these structures are what you see in day to day. It's the infrastructure around you. So from housing, high-rise buildings, industrial sheds, but then also like temporary works and retaining structures. So as a pile designer, I'm commonly provided with, as I say, a phase 1 or phase 2 in terms of site investigation, and that's for a particular site. And I'm asked to design a piled solution in order to meet the performance requirements of a structure. So that could be the applied loads and settlements. So although I still use my geology degree, I'm also kind of looking at the civil engineering side of things as well. So this was a project that I was involved in. I'll give you a little bit of a brief overview of this. So I designed the bearing piles and a contiguous piled wall for a college in Manchester. So in terms of the process that I follow, I would review the structural and geotechnical information. So as I say, that's like the boreholes, and these are just like little snapshots taken from larger drawings. And then I would also liaise with the operations team to try and understand what is achievable and constructible, because that is very important in my role. And then I would also be looking at the, as I said, the site investigation and design software to carry out the designs for the contiguous piled walls. So for example, within my role, that is usually Wallop, and then design the bearing piles, which are separate to that. What I also quite like, especially within my role, is I get to be involved in the installation side of things as well. I don't get to go to site and install the piles, that's down to somebody else. But what I actually, by going to site and seeing what's been installed, I have an understanding of what is achievable. And also on this particular project, I was involved in the remedial design. So with the contiguous pile wall, which you can see in the bottom picture, certain piles weren't able to achieve their design depth. So then I have to rerun the designs and look at what the solutions are. And then we also encountered historic wells, which were over our pile positions. So then we have to look at moving them and liaise with the structural engineer to understand the implications on the design itself. So in terms of how I got to my role and what I think is helpful once you are in your role, my work experience wasn't in the industry that I am in now, and that was very much because I didn't know what I was interested in. So I did a lot of this within my first and second year, and then second and third year. And although it isn't relevant to what I do now, work experience is crucial, because I mean, one, it gives you the opportunity to talk about it in an interview, and it shows you're passionate about the industry, but also it gives you various skills that you might have not got through your university degree. So that's like your soft skills, etc. And by doing work experience, you can get a handle on what you maybe enjoy and what you don't enjoy. And if you can get paid work experience as well, that's even better. So in terms of the interview preparation, and when you are going for interview, I know that there are sessions later on that will talk about this in a little bit more detail, but the only piece of advice that I could give is just show passion for the industry and that you're willing to learn. And you may not have all the qualifications or all the requirements that they have on the job application, but if you've got that willingness to learn and you show that you want the role, you may not necessarily need all the roles and responsibilities that they're stating. And then once you're in that role, I think it's important that you keep up with the learning and to attending CPD presentations and webinars, etc. But also asking questions, because your learning never stops. And I think in terms of my particular career path, I took a geotechnical engineering role on with a geology background, which a lot of people are doing, but I had to work pretty hard initially to try and understand the core principles of engineering, because I knew the background from geology, but I didn't have that engineering civils background. And it was very much a steep learning curve, but I suppose because I wasn't dealing with the hard geology, but I was having to understand material behaviours of soils, rocks, and structural aspects. such as like the steel and concrete, and how that performed over time, which, as I say, is very much the civil aspect. And then in terms of going forwards as well and pushing yourself within your role, recognise where you lack knowledge to carry out gap analysis, etc., because that will allow you to perhaps in appraisals, etc., like ask questions and say, oh, well, I'm interested in looking at for example plan, or you're looking at material properties, etc., and then you can the industry that you're in will help you. And if you have got any questions, I'll try and answer them all at the end of today's presentation once all the speakers have spoke. But then also you can reach me on LinkedIn or via my email address, and I'm happy to help either as a geotechnical engineer through my role or through the FPS chair as the ECG. Thank you.
Thanks, Julia. That was brilliant and really helpful. So next, Wesley, are you ready to go next?
Yeah, we're ready to go.
Thanks, Wesley.
Okay. Right, is that okay coming through? Can you hear me?
I can hear, and it's full screen. Yeah. Brilliant.
Okay. Thanks. Hello, everyone. So to start off, my name is Wesley Dixon. I'm a senior engineer and geologist at Structural Source Limited. There I am, basically looking at some London clay at Bradwell Power Station. Prior to becoming a senior engineering geologist, I got a degree from Leeds University, and prior to this got a master's from Newcastle University. So for what the job actually entails, we've got small interpretive work, which is usually done by these sorts of rigs where we go through soil, window sampling and cable drilling. This is for like 1 to 2 story buildings. Then when we get the large jobs, say your HS2s or Lower Thames Crossing, that tends to be with rotary rigs, and this is tends to go through core or down to around about 200 meters depth. We can have supervisor roles as well, so site supervisors, usually logging managers. This is at Welfare Power Station, where we've got about 6,000 meters of core there, to be if you're like the logging supervisor. We've also got technical reporting, which is what I currently do, as well as tendering, which is where you basically price up for the work that you're doing. So an example of the technical reporting is I usually get a photograph of core such as this one and a log like this. It's my job basically to have a look through it to make sure that the information is on there isn't going to contradict anything that we've got on site, and to make sure that that's correct before we send it off to the client. One of the other things that we do is optical logging, which is effectively just putting a camera down the borehole once it's being drilled. So we have a computer here and a camera there, which will look at that in cross section. I don't have a GIF of it, so I had to make something on Microsoft Paint. So we've got our engineer up here, like this, lower his camera into the hole, then it comes back up, and it gives us an image like this. So one of the ways that these images can be used, because these are accurate to the millimeter, whereas with drillers, they can be out by quite a bit, is, say, for example, we have some core like this, which has been photographed, but we've got the optical log. You can see in the optical log at about 75.75 meters, there's a band of quartz, but then if we have a look at the photo, that band isn't there. So an example in this case is that the driller would have put the core in the box the wrong way around, and this is where, say, the optical log would come in handy. So, from a design point of view, if things are out by, even half a meter, that can cause detrimental effects like buildings cracking or things failing. So that's one of the aspects of what I do with the technical side. So post-university timeline, how I got to where I am. 2011, I finished my degree in geology, and of course, we were just coming out the end of a recession. So during that time, having a look at jobs, it seemed as though my only options seemed to be medicine, recruitment, engineering, or a subcategory I like to call other, in which a job was probably too dangerous or probably not really legal to begin with. So I decided to go for the engineering route and do a master's in engineering geology. And so a steep learning curve for me is an understatement, because they required, well, asked for A-level maths, only had GCSE. So I did find it quite difficult, but I'm glad that I had undertaken it and done it in the end, because I feel as though it's paid off. Whilst I was doing my dissertation, I began job searching. I was applying for months and months, and then in a week, I had 4 companies all get back to me at the same time, which was quite interesting. Of course, I applied, I accepted the one at Bristol for structural soils. So for the first years, I was a graduate engineer, and you find at this point, it's the most frantic and stressful, at least for me, because, you know, it's a new job, a new environment, you're trying to adapt. But, you know, over time, you do get there in the end. After this, I became an engineering geologist, and you find that, of course, the, you know, stresses and stuff of the job can still be there. You just learn how to deal with it a lot better, because you deal with situations before. It's like, what did I do last time? So it does get better as time goes on. And for the past year, I've been, yes, senior engineering geologist, doing more of the technical side, as I'd mentioned, more management. So for people listening now, what can you do to help? One which I think tends to be quite understated is getting a driving license. Basically, prior to working at Structural Soils, I'd only ever driven one of these, and that was for my driving test. I didn't have my own car. So when I was then all of a sudden week 1 told I have to drive one of these, it was a bit daunting, to say the least. And I got a reputation of damaging vehicles, backing them into walls, because I just wasn't used to doing it. It was the most daunting part of the job to start with for me. But the company now have an initiative where, with new drivers or new graduates, they send them out with instructors, so that they get used to driving large vehicles, because, you know, you will have to do it quite a bit. Another one is interview technique. I made the mistake of turning up to interviews, not doing any research about the company or interview technique at all. I just thought I could wing it. I wouldn't recommend doing that. You know, research as much as you can about the company. Look up online, if you just say type in interview questions, go through each one and think, well, how would I answer that? You know, there's a limit to the amount of questions people can really ask you in an interview. As long as you've not had a set answer, but have an idea of what you would say for each question, you shouldn't really get caught out when you go to them, and it makes you a lot less nervous. One is think long term. It tends to be, especially with graduates, we get some that start and straight away they want to go out to, you know, really large sites and just you know, really get into it. I had a couple of years back, a graduate was doing core photography, and he basically ended up swearing at me, because he said, you know, why should I be doing this photography? I just want to go out on site. Let's just get a photographer in to do it. So a couple of months went by, I left him to it, and it turns out, you know, his photos were actually so bad, he had to get them out and redo it. So even though there will be tasks when you start out which you think, you know, I don't want to do this, you know, it could be beneath me, it could be a bit boring. You know, there's a reason why. If you don't get the basics, then, you know, you can't really be trusted to go out to a large site where there's going to be a lot more responsibility. Another one is expect to make mistakes. So throughout college and university, you know, you kind of taught to, you know, try and get things right the first time. You know, mistakes, they do happen, and not always your fault. One of the examples is, again, one of the first few weeks when I was at Structural Soils, I was told by someone to drive to Somerset to dig a pit and get soil for contamination samples. The map he gave me wasn't very good. I didn't think to ask him for a more accurate one, so I drove out, dug the pit, brought the samples back, and that's when he said, well, you know, if you're going to sample soil, you need to sample each individual strata, not just the entire thing from ground level to 1.2, because, you know, you don't know where the contamination is. So I went back the next day, got my digging tools out and heard a woman behind me ask me what I was doing. Long story short, it turns out I was actually in the wrong place, and I dug up a woman's front garden. Luckily, she saw the funny side to it, but other people wouldn't. And if I just asked a question of where exactly the site was, obviously that wouldn't happen. That leads on to the next thing, which is don't be afraid to ask questions. Basically, another example, which just relates back to the driving, is I was given the task to drive a Land Rover Defender, and I didn't know where the lights were. I thought I'd look silly asking where's the lights in this vehicle. So went to site, thought I can get back before it gets dark. I couldn't, so was now driving in the dark with no lights, with people beeping their horns at me. Ended up having to pull over in a petrol station, phone up the office, have someone come out and meet me to show me where the lights were. And understandably, people didn't stop going on about that for quite a few weeks. But if I just asked a question to begin with, where are the lights, it would have saved a lot of time and embarrassment. So even if you think, oh, this is a really silly question, you can guarantee that it'll be better off just asking it than to think, oh, it's fine, I know what I'm doing, and for there to be detrimental effects later on. If anyone has any other questions, those are my contact details with my LinkedIn. Thank you.
Super, thanks Wesley, that was a great presentation. So next, Katrina, would you like to share your presentation?
Yeah, sure, okay, I will.
Great.
So, bear with me. Can you see that? Okay.
Yep, it's all ready to go.
Good. Okay. So I'm Katrina. I'm an early career geotechnical engineer with 4 years experience working in the offshore industry. I started my geology career studying for a MGeol degree at the University of Aberdeen. Obviously, being based in Aberdeen, my degree was mainly focused on petroleum geology. For my field mapping, I went to Mull, mapping igneous rocks, and for my research project, I interpreted volcanic features on 3D seismic data in a basin in southwest Australia. So when I graduated, I applied for several jobs, wasn't really sure what I wanted to do. And about 6 months after I graduated, I was offered a role as a graduate geotechnical engineer for a marine trenching contractor called Ecos Subsea Systems. Ecos owned a number of subsea ploughs and root clearance tools which were used to install cables and pipelines offshore. I knew nothing about this at uni, and everything that I learned this far in my career I've just picked up as I went along. Whilst working for them, I had my first trip offshore in the Moray Firth. The image on the right here is a picture of the back deck before the plough is lowered to the seabed, where it's then dragged along, and then the cable is laid in the trench that is dug by the trencher. So during the trip, this trip in particular, we installed the Caithness to Moray submarine cable, which is in this image here, which goes from the Moray coastline up to Wick in Caithness. And Ecos was bought over by an American company called Oceaneering in 2018, and I joined the Renewables and Subsea Projects group there. In 2019, I then left Oceaneering to join Turning Energy, which is my current role, and they're a marine geoscience consultancy based in Aberdeen. So I'll move on to a bit about what I do in my role as a geotechnical engineer and what I enjoy most about the role. So at Ternan, we work across all offshore sectors, including the oil and gas, wind, wave and subsea cable sectors. The type of projects that we work on range from front-end desk studies and geological site assessments. With these, the aim is to discover what do we know, what don't we know, and what do we need to know in order to plan a site investigation for the development of an offshore foundation or structure. Geohazards or geological constraints that could impact the installation of the infrastructure. So we conduct geohazard studies such as sediment mobility, which can, as the sediment moves across the sea floor, it can uncover either the foundation or the cable, which can lead to structural damage. So we take all of this information and the data that we collect during geophysical and geotechnical site investigations, and we construct 2D and 3D ground models to capture the variation in the ground conditions across the site and provide profiles of the geotechnical parameters required to design and plan the foundations, pipelines and cables being installed offshore. So as you can imagine, coming from a geology background, this is the part that I really enjoy. I like taking lots of data and making models to try and help the engineering, which is the end goal, is to build these structures offshore. So an example of the types of project that I've been involved in recently is we conducted a series of site-specific assessments for the recent Scotland leasing round, where a number of wind farms leases will be awarded to different companies. I think the award is in January. I've also created geological cross sections for HDD, it's horizontal directional drilling, at the landfall of an export cable, and consulting on the development of a novel foundation solution for a new wave energy converter. So I've also included the types of companies that we work or compete with, and I think all but a few of these companies I had no idea existed during my degree. So we work with site investigation contractors such as Fugro and Guardline, who go off and acquire the data that we need to conduct our assessments. We work with the energy developers to develop ground models for their sites, such as SSE and Ørsted. And our main competitors are GDG, Marine Space and Cathy's Associates. So I also thought I'd share some things that I've found useful to learn throughout the development of my career so far. So a large part of my job involves learning new software, such as QGIS, which is a free GIS software, and Groundhog, which is a ground modelling software developed by the BGS. I found plenty of resources online, haven't attended any paid courses, everything's been free. So the types of things you can find online are tutorials on how to use them, YouTube videos, and there's plenty of online forums to ask questions. So in order to learn how to use the software, there's a vast amount of data available online from public databases such as eModNet, Marine Scotland, and the BGS GeoIndex. The BGS are currently running a community science project called the Big Borehole Dig that you can get involved in and learn how to use the software for free, which is quite useful. Other things that I found particularly useful, especially over the last 18 months, is attending free online webinars on different subjects. The organisations that run talks that are relevant to geotechnical engineering offshore are the European Association of Geoscientists and Engineers, who have a local near surface chapter in Aberdeen. I've made use of some of the online courses that you can get on edX for learning about others geological topics. There's a Society for Underwater Technology, and then I've also attended some local and regional geological society events. Pre-pandemic, I also got heavily involved in the Oceaneering Women's Network at the company that I worked for. Their main aim was to support the development of women in particular in technical roles. I think they estimated that throughout the company of about 10,000 people, only 2% of their technical roles were filled by females. So they organised events such as lunch and learn talks on different engineering subjects, STEM events at the local science centre, and social networking events in conjunction with other women's networks in Aberdeen in Scotland, which I found particularly useful to meet new people and find out about different roles that you could do across the industry. And then again, I spent some time volunteering at Offshore Europe, which is a week-long trade show in Aberdeen, where you can find out about all the different offshore industries as well. So again, as with the others, drop a message in the chat or connect with me on LinkedIn and ask any questions, and attempt to answer any that I can at the end of the talk.
Thanks, Katrina. That's absolutely brilliant. So the next presentation is from Richard. Are you about, Richard?
I am, if you can hear and see me.
Yeah. Great. Yeah, I can see the screen now.
Yes. All right, brilliant. Okay. Hi, everyone. My name is Rich Luca. I am from Fugro. I have been with Fugro for just coming up to 5 years. I'm a project engineering geologist. I started at Cardiff University and did a bachelor's in geology. I then did a master's in mining geology at Camborne School of Mines. Right, I'm just going to go through what I'm briefly going to talk about today. So who are Fugro? What is engineering and ground investigation? As someone who came out of uni, I didn't actually know what this was or even that it existed. What departments I get involved with at Fugro? Nearshore site characterization, which is slightly different and specialized to Fugro, software innovation, and then a little bit about careers. So Fugro is a multinational company. We have offices all around the world, and we operate in a lot of different markets. So engineering, geology, and ground investigation. So if you aren't aware. So ground investigations are used to determine subsurface soil and rock properties. And as an engineering geologist myself, it is up to us to undertake all these activities and factually report what we find, and then interpret that data based on the further use of the land. So the departments that we get involved in. So Fugro started out as a CPT company in the Netherlands. So if you don't know what that is cone penetration testing. That is a way of gaining in situ soil parameters by pushing a cone into the ground. As you can see from my screen, you can see a nice graph to the left. So this is recording the sleeve friction, the cone resistance, and the pore pressure. So in terms of in situ testing, so this is something that as an engineering geologist, I get involved in directly. So that's things like packer testing, pumping testing, HPDs, and self-boring pressure meters. So personally, I am someone at Fugro that undertakes packer testing at Fugro. So something I directly get involved with, as well as the CPTs of processing this information. So geotechnical sampling and intrusive investigation. So this is your intrusive investigation as part of your ground investigation. So as an engineering geologist and a contractor, so we go out and do that investigation. We have a large resource pool of rotary rigs, cable percussion rigs, window sampling, and trial pitting, as well as our brand new sonic rigs. So we go out and undertake these activities. And as myself, we supervise these activities and then log and record the information that we find. So as you can see, some nice photos from central London, Scotland, and in northeast up in Yorkshire. And then to the right, there's some monitoring while drilling data. So that is something that I've processed myself. So it's something I directly get involved in as well. So I'll briefly touch on geophysics. So it's not something that I do, but it's something that I need to know about. So at Fugro, we have a dedicated geophysics department. So as you can see, some optical imagery, some caliper and natural gamma data, as well as some check shot data. So as supervising and running a ground investigation is something that you come across. And as part of our graduate rotation program, you get the opportunity to be a part and go for a couple of weeks within the geophysics department and go with the surface and the wireline logging team. So geoconsulting. So as an engineering geologist, you're based within the geoconsulting team. So that is going out, undertaking the investigation, getting all that information, and then factually reporting, and then interpretive reporting. So that's the consulting side. So as you can see, there's some integrated log to the left with some CPT data, some trial pit sketches, as well as then some ground modeling using Leapfrog and some other software to the right. So laboratory testing. So we have two big labs at Fugro, but it's not something that you just send your samples off and they get tested. With certain jobs and certain projects, myself, I undertake the laboratory testing on site. In the nearshore environments and marine environments, it is something that as an engineering geo, you get involved with and you have to undertake. So you can see from the left, that's one of our lab containers, offshore lab containers that we undertake these activities in. So operations and project management. So as an engineering geologist, you're not going and looking at the geology, but you're also running the site, and especially if you get higher up and more senior within your career. It's about managing the projects so you can get involved in the tendering and in the site management. So myself, I am directly involved within the project management teams at Fugro. So this is something that I directly get involved with as a site agent or something like that. So nearshore site characterizations, this is something that's quite specialized to Fugro, especially to the land site characterization department. So we undertake overwater ground investigations using jack-up barges. So this is slightly different to the marine and the vessels. This is slightly more shallow water. So as you can see, we have purpose-built jack-up barges that you live on, that you don't live on, to undertake these activities for renewables, for wind farms, for jetties, all different types of activities. This is something that I enjoy the most. This is something I absolutely love. I love doing these jobs, being with a small team, being right next to the rig, undertaking the activities, doing all the lab testing and things like that. It's really good fun. So it's a nice photo of one of our contracts we did in central London a few years ago. On one of our jackups. So software innovations. So Fugro, we have designed in-house our software that we undertake all our logging, borehole logs, trial pit logs, everything like that, as well as our drillers logs. This has been developed over the last 2 to 3 years, and we have a dedicated team of geoscientists that have worked on this, have developed this, as well as just being out on site. They also undertake this as well. So careers at Fugro. So you have lots of opportunities at Fugro, especially with the graduate rotation scheme, the UGRO mentorship program. So a quick one about the opportunities at Fugro. We had a graduate engineering geologist who started with us, went out on site. We realized he was really good with computers. As of this year, he is now the geodata digital transformation lead for Southeast Asia and moved out to there. So there's so many opportunities to specialize. I know some of the other guys have said it, to find out your niche, find out what you're good at and move into that. And I'm going to finish on a few slides. So what got me into this industry and what I love is geology. So I'm just going to finish on a few slides of geology because that's what keeps me interested and makes me love the job. So we've got a nice picture on the top of some chalk with a big old dissolution feature. So this is prime what we're looking for a ground investigation. In the middle, we've got some glacial till from the Baltic Sea that I was on a couple of years ago. Some very colourful Lambeth Group lower mottled beds from central London. You've got some Portland limestone. Bottom left, you've got, it's not always we drill through natural ground. You've got the base of a dock key wall going into the chalk below. And then to the right, we have a possible plesiosaur femur that was found in the Kimmeridge clay on a contract that I'm currently on only a few weeks ago. So I'm going to finish as a quick photo from the mob that I was on in the Irish Sea this year. So going to finish with at Fugro. I love it at Fugro for the fact that you get to experience not only the little bits, but you get to be involved in everything around ground investigation and engineering geology and get to be involved in that. I believe it makes you a well-rounded engineer and geologist, and it's something that I thoroughly enjoy. All right, as you can see, you've got the Fugro Careers Geological Society. You can go on if you would like to know more. My email is in the bottom right-hand corner, so if you want to email me with any questions or anything, you can. Like myself and Harry and a few other, the Fugro team will be at the Gather Town on Thursday as well, so you're more than welcome to come and ask us any questions. Thank you very much.
Great, thanks, Richard. Sorry, getting a bit of repeat from me. I'm not sure what's happening. So we have got some questions coming through, which is great. So one I'd like to throw out to you all is, what are the typical qualifications required for entry-level positions in your companies, size or undergrad with additional experience? Julia, do you want to kick this question off?
Yeah, certainly. So in terms of the my particular foundation design, etc., I think it's not necessary for you to have a master's, and especially, I suppose I'm a prime example of that. Is although I had done an integrated master's, so I'd done my 4 years, I then realised that I needed to upskill in order to progress further within my career. So then the company sent me back to university, and that was funded through them. And I think, as it was almost kind of touched upon previously, as long as you are willing to learn and show passion for the industry, especially within your interview, then if you've got a BSc, then that is sufficient, because we're willing to teach you and help you develop.
Great. So Wes, would you have anything to kind of add to that?
No, I'd have said, yeah, pretty much the same thing. Getting the master's or PhD, obviously it's helpful, but it's not essential to the role. Like, if you turn up, you go through the interview and then they're like, well, hang on a minute, like, you've only got a BSc here, not an MSc, like, you know, we're not interested, that wouldn't happen. It's if anything, kind of a gateway into the career or the interview process. But once you get to that, it almost then, it doesn't become irrelevant, but then it's more a case of, well, what can you yourself bring rather than what qualifications are down on the paper. Like we've had people start with us who have had PhDs, and because of that, it's not going to be a case of, okay, you're going to go straight into a senior position. They'll still start as a graduate, they'll still do the same things that people did. It's just that they just might have a bit more of a background knowledge of it, but it's not a make or break. If you've got one, it's good to have one, but it's not essential.
Great. Katrina and Richard, if you have anything to add to that, that's great. But I'd also like to throw into the mix chartership. Are any of you chartered or working towards chartership? Do you think it's helpful?
Yeah, so I'll jump on the back of the previous question as well. I completely agree with other panelists that it's you don't necessarily need a master's or a doctorate to enter the industry. It might have been so 5-10 years ago, but now the amount of jobs out there, especially in the market at the moment, there is more than enough opportunities to go into the industry with an undergraduate. And I know the other guy said in the previous session, we have a few staff that are doing part-time masters next year, so it's something that Fugro and we definitely do. So it's it's not essential, but it's a nicety sometimes.
Yeah, so I can add in as well. At my current company, there's 5 of us who are considered early career, and we have one person with a BSc, I have a MGEL qualification, and 2 people with postgraduate masters, but in completely separate subjects. So structural geology, and then is someone with a geochemistry degree. So I think speaking for all of us, what we'd say was that the studying what you're interested in first and foremost is the main thing. And when you get to the interview process, if you can show that you were passionate about what you were learning, that counts a lot more than having a relevant postgrad qualification, because you can get them later. And with the chartership, I'm currently working towards it and plan to go for it next year. So I'm pulling together all my documents at the minute and reflecting on my first 4 years. And it's incredibly helpful to see what you've learned and what you haven't learned. So yeah, I'd say chartership's useful to help you build confidence and to see how far you came so far, and to then highlight points maybe where you want to go a bit further.
Great. So we've got some questions in the chat box too, so I'm just having a look. Someone said, can you comment on the possibility of geologists in the Pacific pursuing a geology career in the UK? So I'm guessing that's overseas graduates, maybe?
Yeah, I mean, within the UK, especially in geotechnics and construction that I'm aware of, we do have a skill shortage. So I think as an industry, we are looking for people to fill those graduate positions and other positions within the industry. I don't know how it works in terms of I suppose it's Brexit's irrelevant if it's the Pacific, but I don't know how it works in terms of working within the UK and visas, etc. But I'm sure the recruitment people tomorrow might be able to help you further on that. I also had seen a question just with regards to decided to pursue my master's in geotechnics and now actively looking for jobs, but they don't have any relevant internships or professional on-site experience within geotechnical or the hydrological engineering industry. I mean, I can start first, but I can imagine everybody else would fill in. With regards to on-site experience, etc., I don't think it isn't necessary. If you are looking for roles, there's obviously companies available here that you could contact, and we're all available to have a chat. But also use LinkedIn. LinkedIn is huge within the industry, and there's a lot of roles that you can apply for through LinkedIn and through then the companies that you could find within LinkedIn. If you type in maybe geotechnics or ground investigation, site investigation, kind of look at your keywords and search for them within LinkedIn.
That's really helpful. Thanks, Julia. Yeah, I agree. LinkedIn is huge and it's a great place to start. So even if you haven't necessarily got a relevant job history, it's good to have a profile and write about what you're seeking. So I'm just having a look further down for questions. There's someone that said, I do not have a relevant internship or professional on-site expertise within the geotechnical hydrogeological engineering. However, I decided to pursue my master's in geotechnics and I'm actively looking for jobs. Any recommendations on how to approach the industry?
Jump in a bit on what Julia said there. LinkedIn is definitely the new way to network. A bit of advice I would give is if you see a company or indeed a person who is in a job role that you like, it can't harm you to send them a message and ask them any questions. The worst they can do is ignore you, so there's no harm done. So I know my first role, I met a senior geologist through the Golf Society that I was a part of, and I met up with him for a coffee, asked him a few questions, and he was incredibly helpful in just sending relevant jobs that you could apply for that you wouldn't see anyway. So connecting with people on LinkedIn, they might share companies or like content from companies or jobs on their LinkedIn pages as well that you can pick up on, and you maybe find relevant roles that way, as well as on the regular job listings that you get on LinkedIn.
Richard, I see there's a question for you as well. It said, can you please share some of your experiences in the field?
Yeah, of course. Okay, so I started out from my master's, started out in mining exploration and worked out in the field a bit from that side of the business, and then moving into the geotechnical with Fugro. So I spend predominantly most of my time out in the field. So now as a site agent and technical lead on everything from small jobs to large jobs. So that's on offshore jack-up barges, supervising as the senior geologist on board. So that's from the logging, lab testing, in situ testing. And then out on land, it's then logging still, playing a big part in training our new staff coming up. So from core logging, cable percussion, and then obviously from the site agent part, so that's the management part of it as well. So yeah, I'm predominantly field-based and site-based from all these sort of activities. So my experience is pretty much just site and field-based from the start of my career, right to still right now. I'm still out in the field, right, as at the moment, apart from today.
Thanks. So I'm just having a look. So someone in the chat has suggested to just recommend to approach speculative employees like a director or a senior manager, and they said they did this at the beginning of their career years ago. So thanks, Alistair, that's helpful. So I would like to kind of finish. We've got 5 minutes left of this session. And I'd like to ask you what you think the future holds for this area. We could do a whole session on this. Kind of quick fire round. We'll start at Wes. What do you think the future holds for geotechnical engineering, engineering geology, etc.?
One of the things definitely for geotechnical or engineering geology and at structural soils and other companies seeing is everything or almost things being computerized or like using tablets. So I started working there around about 9 years ago, and any data collection we were doing was all on pen and paper, and it's just a case of it's just what we'd always done in the past. Of course, with that, if it would get lost, you wouldn't be able to read handwriting sometimes. And eventually we started to, utilize tablets on site for the engineers. And, some people didn't like it. Sometimes I want to carry on using my notebook. What we find now, we're pushing more towards using that, which I think is can improve things, because we can see in real time when people submit information, it's a lot harder for it to get lost as well. You can see exactly who's done it. It just saves a lot of time from, say, someone being on a site 200 miles away to someone in the office having to process the data or wait for it. So that's where I see things are going. There won't be, pen and paper will be a thing of the past.
Great. I'll pick on Julia next. What would you say?
So I'd second that with regards to what Wes has just said. Definitely everything moving towards a digital infrastructure, but then also a more sustainable industry, which I think was talked about briefly before. And especially within civils and construction, there's definitely at the moment a change to the materials that we're using within our foundations, and we're looking at low carbon solutions, the reuse of foundations, and how we can look at different techniques that mean we're not putting more concrete in the ground that is necessary. So I think, definitely a sustainable push.
Right, so I'll pick on Richard next. What are your thoughts?
So I'd agree with previous two that digital transformation is massive at the moment. It means that we can send off our deliverables straight to the client immediately. It means everything can get processed, which is really good. Health and safety is something that I've seen massive through my career, from starting out to now where it is right now. So it's a massive thing that will only get better and increase over the next few years. And for Fugro, it's the renewables. The renewable sector is huge, and we're only seeing it in the last few years, and especially we're coming into next year with the wind turbines and wind farm contracts. It's definitely the future of offshore and the geotechnical and engineering geology.
Super, thanks, Richard. Last but not least, Katrina, do you have anything to add?
So I'd add my agreement about the digitalisation, especially since pandemic. It's I don't use paper anymore, and also I think in the offshore industry particularly, as long as we're going to be building things offshore, we're going to be needing geotechnical engineers, whether it be oil and gas platforms, wind turbines, or relatively less developed technologies such as wave and tidal energy, which are a massive thing. They're effectively where wind was 20 years ago, and there's so many new technologies that they're trying to develop and push at the minute to get them ready for deployment. And then also how you can tie the technologies together. So whether it be like an energy island type idea, or combining the use of wind turbines and wave energy devices as well. So yeah, anything new that you can bring, new ideas that you can bring are always welcome.
Thank you. So that brings us to the end of our session. Thank you to all the speakers. You've been great, and I hope you've inspired everyone. We're going to take a short break now, but just before that, I would like to encourage you to come along to our networking session tomorrow. It's taking place at 4:15. And it's brought to you by our platinum sponsors, Fugro and the University of Edinburgh, and our gold sponsors, the University of Manchester and the Institute of Quarrying. I'll just play you a short video now, so you can see kind of a little bit of what's to come. And this is from Edinburgh. One moment, I'll just reshare. Thanks, everyone. We'll be back at 2:30 after a short break. It's a session on data, and we've got 4 wonderful speakers. So hopefully I'll see you back at 2:30. Thank you very much. Sorry, everyone. I heard that you couldn't hear the recording, so I'm going to try it one more time. Emily or Alexandra?
Hello.
Hello. Could you let me know if you can and can't hear it?
Yeah, no worries. Yeah, I haven't heard a single thing so far, so yeah.
Okay, I'll try it now. One moment.
Hello, my name is Isabel Graham-Smith and I work in the market and recruitment team within the School of Geosciences at the University of Edinburgh. I wanted to give you a little bit of information about the School of Geosciences and what we do. So we have a range of undergraduate and postgraduate degrees in geography, earth sciences and ecological and environmental sciences. And our interdisciplinary programs span a wide range of natural and social sciences and the humanities, which provides our students with unique opportunities to explore and tackle global challenges. Our programs are taught by world-leading academics in their fields. For example, some of our academics have contributed to the IPCC report on climate change, which is used by world leaders to tackle the issue. We have one of the UK's largest groupings of geoscientists and geographers and a large range of specialist facilities which are used in teaching. And finally, the university is consistently ranked in the top 20 universities in the world. We're currently ranked 16th in the QS World University Rankings 2021. So we offer a wide range of degrees in earth sciences, ecological and environmental sciences and geography at undergraduate level, and I've just popped them on the screen here, but I won't read through them. And a wide range of interdisciplinary programs at postgraduate taught level too, spanning from applied environmental hydrogeology and geoenergy to environmental sustainability and geographical information science. So there's a huge variety of degrees. You can find out more about our postgraduate taught programs at our upcoming postgraduate virtual open days. We're hosted a variety of live sessions between the 9th and 11th of November 2021, including a keynote session on climate change. Information sessions about our postgraduate taught programs will be hosted on Wednesday, the 10th of November. And for information about postgraduate research options, you can join us on Tuesday, the 9th of November. And you can book your place on our website or follow the link on this slide. We'll also be available at the networking session during the Geological Society Careers Days on Thursday, the 14th of October at 4:15. And if you can't make the networking session on Thursday, here's a list of our social media accounts so you can keep up to date with what's going on with the school. And we hope to see you on Thursday.
Hi everyone, welcome back. We're about to kick off our first session since the break. So up next we have geodata, risk management and AI in geoscience. On the panel we have Alexandra Cristobal Huerta, Stefano Di Sabata and Emily Riley. So Emily, would you like to kick things off and do the presentation first?
You may just have to tell me how I share my screen. I'll be honest with you, I'm not used to Zoom.
It's can you see along the bottom?
Oh,
There's
the big green one. Yeah, that's obvious. Okay, good start. Okay. Can we see this okay? Yeah.
Yep, you're not in presentation mode.
There we go.
Yeah,
Yep,
perfect.
all good, great. Yeah, so hello everyone. So my name is Emily, and I just thought I'd introduce kind of, I guess, my career to date and kind of where I am now. So I did a BSc Geological Oceanography at Bangor University, which I'm sure is a course that hardly any of you have heard about before. Basically, rocks underwater is the main thing you need to know there. So I started off doing a BSc first. When I graduated, I joined a main works contractor in the construction industry called Costain. And straight away in that graduate scheme, I joined quite a large infrastructure project that some of you may or may not have heard of, called Thames Tideway. So I worked on the eastern section of that project as a geotechnical engineer for about 4 years. I then, at the end of last year, went and did a secondment. So a secondment is sort of long-term work experience. So you still work with your parent company, but you get experience somewhere else. So I was with Mott MacDonald for a few months. And then earlier this year, I moved over to Card Geotechnics Limited, CGL, as a senior engineer. And this is a glorious photo of me at the base of quite a deep shaft at Tideway, with a lovely fissure in the chalk, which is what I was staring at for most of the time, which was great. And then I should probably also mention, I'm not done with education. So for the past few years, I've also been doing a part-time master's in geotechnical engineering at the University of Birmingham. So I'm sort of working full-time, but then also still very much in student mode too. And then education and kind of work aside, I'm also the chair of the British Geotechnical Association Early Careers Group. Again, might not be something that you've heard of, but we're there to kind of network with students and early careers professionals and to help kind of guide them through their career. And I'm also on the committee of the engineering group of the Geological Society as well. So I'm half geology and half geotechnical. So when I was thinking about what this sort of section of the day was going to be like, I myself hadn't actually heard of the phrase geodata before, so it was quite nice for me to look into exactly what this definition was. But when I started looking, it was quite relevant for me. I use a lot of these sorts of mapping systems in my day-to-day role. So I just thought it would be helpful to kind of set the scene of exactly what geodata is. So it simply, refers to any kind of data and information that has an association with a location relative to Earth. So you can include anything in this map as geodata. So it's not just two site investigation locations, the nature of having a transport line. This is the Jubilee line here, indicating kind of streets names and any properties associated with those streets. Not on this image, but you can have anything associated with elevations, topography. So if you're in a really hilly area, you want to know where it undulates a little bit more, and obviously where elevations are higher. And you can also have hydrography, so the inclusion of lakes, rivers and their associated tributaries and networks, because all of that, is useful to kind of build up a big picture of what you're looking at, because half the time we're looking at trying to solve problems. So having all the information in one place is quite useful. So another cool thing that's, I guess, specific to my job, I do a lot of work in London, and we have a lot of features that are shaded here in red, which are called drift-filled hollows. So they also used to be known as pingos and scour features, if there's any geologists in the virtual room. And essentially they're pockets of where your traditional London geology has been, is not in place because of large glacial processes back in the day have essentially just infilled a lot of old gravels from kind of when the ice sheets came down this way. So by being able to use geodata and by using all of the ground investigation data that we have, we're able to fairly accurately plot where these mixtures of sediment and gravels are that you know we need to keep an eye on, because it deviates away from kind of where we would have traditional ground, I suppose. There's been lots of work done recently to try and make a big map of these. So being able to incorporate these into GIS systems is very useful, particularly as I'm looking at some work in this area at the moment as well. So it's good to have this here. So I thought that was a good example. But geodata can be anything. A large portion of my role is associated with site investigations. So even when you're trying to do logistics planning of where you might be putting a borehole and where you might be needing to look for features, you can have an aerial view of images, you know, to get a sense of where you are, you know, in relation. This is a tunnel route, for example. You can also start to use actual geology in here as well and have some cross sections. So, you know, you can overlay the information that you already have, and you can begin to see variations between kind of the borehole logs to try and make a little bit of a layer of each strata, as you can sort of see on the image here. So it can be presented in kind of various forms, I think. And this is a great way, by having these sorts of cross sections in my job, dealing with risk and ground risk. That's huge. You know, it will always be something that we have to spend a lot of time and research on at the start of a big project. When you are tunneling, for example, you want to make sure that, you know, there's nothing above or below that could be impacted during the tunnel process. And you want to make sure, again, going back to the scour features, that everything is as we are expecting it to be. So by being able to map up and visualize the data that we have, which is often so much data, being able to visualize it can really help to de-risk some situations for us, which is very valuable in my day job. But I just wanted to end with a few more slides of some photos, just to maybe highlight the obvious, but you would be surprised how often sometimes this is missed. There's a classic phrase, you know, good data in, to put it politely, you know, good data out. So we wouldn't be able to make any of those cross sections and any assumptions following those without having really, you know, as high quality as we can, ground investigation data at the start of it. You don't want to be plotting anomalies, for example, and thinking that that is, you know, real and that is reflective of the environment that you're in. So good drilling techniques, you know, following all of the, you know, various specification best practice guides, that will always be really important. And similarly, some photos here of some chalk, because I quite like chalk, but records on borehole logs are so important, because we will put some of this content into our geo systems that we use. So we have to make sure that it's been logged appropriately, and you know, it is truly representative of, you know, the photographs of the core and kind of what was found at that time. And a way that we would do this is by also getting specialists to come and ground truth, so to speak, some of our data by validating that we are logging correctly, and we've got all the various kind of bands in place, and we're grading appropriately. So this is a really good internal way of validating that, you know, any data going into your future database has at least some robustness to it. And then finally, speaking of ground truthing, I also just wanted to mention, I guess, a different form of geodata, and I can't quite remember if there are other talks on this, so I'll only kind of spend a minute or two on it. But because I was on a tunnelling project in central London, particularly the eastern section, and a lot's been happening in the Canary Wharf area for quite some time now, we collaborated with Imperial College to operate a PhD using INSAR. And because I always forget what the definition of INSAR is, I've written it here for everyone. It's quite a wordy one, so I'll stick to INSAR. But essentially, it's satellite monitoring, and we measure kind of changes in ground motion by comparing the distance between sensors and the ground surface at different moments in time. So you're constantly scanning and you're comparing the results with what you had previously, to assess if there's any ground changes. And we can get kind of millimeters precision depending on if we've got a good coverage of reflectors and the like. So that's essentially how it works. And as I said, East London, so our project was here. There's lots of already known faulting, drift-filled hollows, as I'd said, a lot of Battersea, for example. So, being able to use satellite monitoring to get more precision versus what we could get on the ground, that was really important for us. And all of that information constantly fed into our tunneling progress, to make sure that we weren't doing anything untoward. And so I've referenced the Imperial College PhD there and the lead kind of author on that. So I was aware, I think I only had 10 minutes or so, but I wanted to kind of start talking about geodata, and it'll be interesting to see what everyone else has in their slides, and then I guess we can take some questions.
Thanks, Emily. That was brilliant. So the next speaker is Alexandra. So please could you start to share your presentation?
Yes. Okay. Can you see it?
Yeah, I can. Yeah.
Okay. Okay, so, well, good afternoon, everybody. My name is Alessandra Cristobal Huerta, and I work as data scientist at FUGRO in the innovation department. I want to start saying about my education, because I think I might be the only one who is not geotechnical or geologist. So basically, I have a bachelor in telecommunication engineering and a master in information technology and communication in biomedical engineering. And finally, I almost have my PhD in physics and medical imaging. So as you can see, my background is mainly in the medical sector. I want to talk a bit about what is my current role, what do I do as data scientist at FUGRO, some of the current projects that has been done, and things that I like best within my career, and how I got there, why I am at FUGRO. So about my current role, as I said, I am a data scientist, but I am a consultant. I am an internal consultant for different kind of geotechnical or geophysical projects. So I am not attached to a specific line. I am basically consultant for all kind of projects. And how I approach these projects is from a data point of view. So basically, when a problem comes from the business, I analyze the problem. So it can be solved using AI or artificial intelligence, or we can use more simple algorithm. I analyze the data as well. If we have enough data and it's good data as well, as Emily said, good data in is gonna mean a good model and good predictions or classification. And if this data is suitable for solving the problem we want, or we need to acquire other data, or we need to look for data on internet. Then it would come the part of modeling. So there is more what kind of machine learning or deep learning algorithm architecture we can use, and it's more suitable for this project. Yes, for this project. And also all kind of data engineering part. So like we will do like, for example, transformation of the data in order to be more suitable for this kind of algorithm and so on. Then I will analyze the results. Well, me and my team, I am not alone, but we analyze the results. Basically, we check if the model that we developed with machine learning or deep learning is capturing the correlation of the relationship between the input and the output, what we want to obtain. And if it's not working well, why that happens. It's not enough saying, oh, this doesn't work. It's good to know also why not. And in that case, we can improve it and go again on this cycle. And if everything goes fine, we will go to a production environment. So we will design an application that can be used by the users in order to make predictions with these models. So talking about some of the current projects, I'm gonna go really fast on them. But basically we have had one related to soil layer classification. This is for soil investigation. So basically we have a technique that is called cone penetration test, a CPT. So the CPT test, what it consists is on a cone that pushed into the ground, is pushed into the ground, and then it records some signals that correlates with the different type of soils. So it can be sand, peat, clay. So, but for big projects, like for example, we had one here in the Netherlands for a road. They obtain 1,800 CPTs. So, and this is usually done manually. So one geotechnical engineer takes these signals and they classify which part of the signal is sand, which one is clay, and peat. So imagine this for 1,000 CPTs. So this is really time consuming and it's subjective. So what we did with machine learning in this case was to develop a model that can learn what the geotechnical engineer is doing, how it is classifying every soil type in the CPT signal, and obtain an automatic way of doing it. So in this plot, you can see on blue is the cone resistance. So it's one of the parameters that we record. And the different colors means a different soil type. So on the left, you can see what it did, what the geotechnical engineer labeled. And on the right, you can see what the machine learning did for this location. As you can see, it's not perfect, but it's quite good, and it helped them to go much faster. So they only needed to review this pass. So, and with this, what they can do is a ground model of the area in order to minimize the risk of the construction of the road. Another project is about predicting geotechnical parameters from seismic data. So in this case, seismic data was acquired offshore to install the piles of wind farms. This was in the North Sea, in the Netherlands North Sea part. So from different, what we have is seismic data that some some seismic attributes were extracted. With that, we train a neural network that could predict the cone resistance in this case. So as you can see on the black line is the cone resistance, the ground truth cone resistance, so what was measured by the CPT, and on the red you have the signal that was predicted by the machine learning. So as you can see, it's not perfect. It is not good in some cases, but for the purpose was capturing the trend. So this was enough for them. So next, I would like to talk about things that I like best within my career. So why I like my career and I am working on this. Basically, it's because I can always learn new technologies, algorithms, and topics. So it's research related. And I like to keep on learning new things. I work also with great colleagues. They are very knowledgeable on geotechnical and geophysical matters that I am less aware of. So they are always ready there to help me to understand the domain knowledge, to have the domain knowledge. It's also an environment that is suitable for innovation. I have the right tool, and I also have the space for discussing my ideas and proposing new ideas and projects, and also opportunities to grow. I think it's really important that where you are, you have opportunities to grow and go further on your career. And how I did get here, where I am right now. So I always had a passion for technology. So I was always surrounded by computers and gadgets since I was a child. Then, as I said, I did my bachelor in telecommunication engineering. So I had a lot of signal image processing and machine learning during my degree. During my master, I got more knowledge about advanced algorithms. Then I was working for several years as a research assistant in the medical sector, in medical imaging at university. Then during this time, actually, during my research time, I was doing a lot of different mock courses in Coursera or other parts that you can find them. So this helped me to get some other skills that I didn't have at that moment. So then I did my PhD in medical imaging, and this helped me a lot on project management, on research as well, like how to approach a project as a research in the scientific way. And then I finished working at FUJO as data scientist because I got my transferable skills to here. So I don't see things as a domain knowledge in this case. I see the problems as data problems. I have some images I didn't. And this is everything about myself and my career. So if you have any question, please just write me to my email or to my LinkedIn. And if you have any requirement queries, please write to Liz. And also, please, if you want to know a bit more about what positions are open, just go to this website.
Thanks, Alexandra. That was a really good presentation. Next, we have Stefano. Stefano, are you ready to present?
Yes, hi. Thank you for inviting me.
You're welcome. Thanks for coming along.
Try to share my screen. Okay, are you seeing my screen?
Yeah, I can. Wonderful.
Sorry, not visible. Just a second. And slideshow presentation. Okay, so that I can see my clock. I know how long I'm going. Well, thank you again, Becky, for inviting me. I'm glad that Alexander presented before me because I'm also much closer in terms of topics and background to Alexandra than to Emily or probably anyone who is listening right now. So my name is Steph. I am a lecturer in quantitative geography at the School of Geography, Geology and Environment at the University of Leicester. I'm also a research associate of the Oxford Internet Institute of the University of Oxford, and I'm the secretary of the Geographic Information Science Research Group of the Royal Geographical Society. So effectively, I'm definitely not a geologist. I'm barely a geographer. So I actually have a background in computer science, more specifically software design and development, technically, before I moved to geography and geographic information science for my PhD. So what do I do in my sort of like everyday life? And I guess the reason why I'm here is that I work a lot with data. So very similarly to Alexandra, and probably coming from a sort of like the other way around compared to Emily. My main field of expertise is what now we call data science. So in terms of research, but also teaching, I do teach how to deal with data and how to process and analyze data in particular geographic data. And the field itself is usually referred to as geographic information science, although nowadays terms like geographic data science or geospatial data science are also very common. And the image that you see here on the slide is actually from my teaching materials, so it applies very much to what I teach as well as what I do. And this is sort of like a classification of areas, in this case, areas of Leicester, based on the kind of dwellings that are present in the different areas. And this is a classic case of machine learning, artificial intelligence applied to geographic data. So this is a lot of what I do. So I applied machine learning and artificial intelligence method to geospatial data. In terms of teaching, I teach a lot of visualization and cartography as well as database use and information retrieval, which is the part of machine learning and artificial intelligence that deals more with natural language, sometimes also referred to as natural language processing. So how do we get data which are not already structured in a shape file or something like that and try to extract information from simple text, for instance. So in terms of my research, I also focus a lot on topics such as volunteer geographic information, which is, for instance, the information that people contribute through the internet. So that could be things like Wikipedia, that could be things like social media, like Twitter, things like OpenStreetMap, if you have ever heard of it. And this sort of like bridges a lot towards human geography. In fact, I collaborate a lot with my human geography colleagues in terms of what is usually now referred to as digital geographies. And that's sort of like everything that has to do with how the internet and all the digital tools that we use and that we've been using a lot throughout this pandemic to collaborate, to work, to live together. How are they impacting our perception of place, our everyday experiences? To give you an example of the kind of work that I've been doing so far, and hopefully getting closer to some topics that some of you might find actually interesting beyond the general data processing component, I want to just briefly mention two projects that I'm currently working on. So the first one is focused on geodemographic classification. This is an example of sort of like using methods currently being developed in computer science and apply them into different contexts. So taking some methods, changing the methods to fit what we want to do with these tools. So the two maps that you can see on the top, the first one on the left is similar to what we've seen in the previous slide, is a classification of area, in this case in London, based on the people who live there and sort of like a number of variables. I think this is based on about 60 variables, all sociodemographic variables, and that are used to create this classification. This is being created with a fairly long and complex process using fairly standard methods. Now, what you see on the right is my attempt to do something similar with more complex methods that hopefully can sort of like substitute the long process that it takes now to geographers and statisticians to actually create these models, hopefully maybe creating something a bit more complex in terms of the technology, but hopefully a bit quicker in terms of creating this kind of classifications. In this particular case, I'm using deep neural networks with some sort of like some more geographic flavor, in the sense that the way the data are processed through this neural network are not just sort of like, how would you say, they're not as spatial as they normally are, but they are treated as spatial data. So the proximity between the different areas are taken into account collaborate together to create the classification of one single area in their proximity. The example on the bottom is something that I literally just started, and this is possibly again closer to what some of you might be interested. So this is a PhD project, which is part of a sort of like a larger project around resilient and biodiverse forests. So trying to understand and identify existing resilient woodlands ecosystem, in this particular case within Leicestershire and Rutland, and try to understand how they develop and how can we help them remain resilient. So how can we identify areas which are already resilient and how we can sort of foster this. What you see here is sort of like an analysis that's being done by, not by me, but it's been done by Rachel Holmes, one of our PhD students, and within sort of like a sub-project of broader project I'm be part of. So the idea of another PhD project that is now starting with me as first supervisor is to try and see whether we can use the data that this project have collected and are collecting to actually use in combination with machine learning approaches and advanced machine learning approaches, hopefully, to try and create, first of all, create classifications, but also try to predict how these areas might be developing using sort of like long-term records, as well as I believe this is what we will be using, data from the Woodland Trust, as well as probably LiDAR data. Again, it's a little bit, this is a very new project, so we are not quite sure exactly which kind of data we're going to use. And this is the exciting bit. So just to give you an idea, next week, I'm probably going to sit down in a room full of undergraduate students in a pollen lab and try to understand what do people do in a pollen lab. And I might be going to doing fieldwork with geologists in a few weeks' time. So this is something that's completely new to me. In fact, I think Becky suggested, please do put, if you have any picture of you in the fieldwork, and I don't have, I put a lot of maps because otherwise it would be me sitting on a desk in front of this computer. This is me doing work, so I don't really go to the field. So just to conclude, how do I got here? Well, as I said, I started in computer science, and this image, which probably doesn't really make sense, was my first attempt to actually collect some data through GPS and process them and try to identify key areas of, in this case, was me commuting around my hometown, trying to find some patterns into it that I can then use for further processing. And it's sort of like this was in the context, again, of very much computer science. Then I moved into GIS, and during my PhD, I started working with more geographic, this knowledge discovery, as it was frequently mentioned at the time, with geographic machine learning and artificial intelligence methods, in this case for location-based services, so providing information to user on a mobile phone. From there, I then moved almost completely to human geography and social sciences, and I worked for almost 3 years at the Oxford Internet Institute, on which I'm still sometimes collaborating. And in that case, we're still looking at a large amount of data from the internet and trying to extract knowledge, try to understand who participate on the internet and from where, and so on and so forth. And finally, when I moved then to Leicester, I've started to apply this data more, this method more on a local scale, on the urban scale, and finally ended up talking about resilience with some colleagues, and here I am. So yeah, please do feel free to contact me. This is some of my contacts here, and I will just shut up because I've already used more than 10 minutes. So thank you very much again for everybody.
Super, thank you, Steph. That was really interesting, and another angle, which is great. So we've got 10 minutes for some questions. I can see the Q&A is pretty busy. So I'm just having a little read through. What are the requirements for geologists outside Europe for securing, oh, sorry, that's an old one. Please excuse me. So we've got a question about GIS and how important it is. So I guess perhaps Emily and Alexandra, maybe that one's more aimed at you, or Stephanie?
I guess a GIS is such a big, there are so many things that could constitute, for me, in my view, what a GIS is. So my job is a lot of the initial groundwork, literally and figuratively. So site investigation wise, GIS, we go to see if we've already got data in our internal database that might help us with a project. Like I said, you know, we'll update if we find anything interesting, or, you know, if we need to keep an eye out for all the various tunnels in London, for example, we can use kind of these sorts of databases to check against those. So for me, it helps to de-risk my activities, which obviously would have, you know, cost benefits, program benefits from a, you know, a kind of working perspective. But I guess, yeah, I'm more work rather than kind of the academic-y side. So I don't know if anyone else can feed in.
I can say that I very much agree with Emily. I mean, GIS is the term. I would say that up until maybe 20 years ago, if you say GIS, you would probably mean ArcGIS or a few other tools. And nowadays, it's literally everything. I very, very rarely use ArcGIS at all, and very rarely use a standard GIS. The vast majority of what I do is done with R and with Python, literally the vast majority, SQL as well. So all the tools that can provide you programmatic processing of spatial data could be understood as a GIS. And yeah, I think for instance, I think Alexandra was also talking about machine learning, and this is an area which has literally exploded in the last 10 years, especially in terms and around image processing. And a lot of those tools can very, very easily be applied in GIS when you work with raster data, for instance.
I've just seen the other question come in. So that there's another question that says, are masters essential for kind of graduate roles and internships? And this is one that I feel quite passionately about, because as I kind of said in my intro, I got a job really fortunately following on from my BSc. And this comment also says, you know, not sure you want to specialize in something yet without fully knowing kind of if that's what you want to do. And that's the exact approach that I took. I loved my time at uni, but I was ready to try and work in the field. I would say if you are looking at doing kind of just a BSc, I'm sure you all know that, you know, internships, any sort of summer placements, be it for 2 weeks somewhere, is so important. And I was quite fortunate to have a few internships in my time when I was at uni the first time around. So any experiences that you can get, you know, would be hugely beneficial if you are then applying for jobs post-graduation. And yeah, there's lots of companies out there. I think definitely Fugro, I think, supports you know, students also whilst they're working, returning back to university. My company's been great. There's lots of companies that sponsor masters as well. I wouldn't say that everyone does, but you know, that's also a financial, you know, potential benefit. So yeah, I would absolutely say, you know, if you're not sure you want to specialize yet, I would hope that with good experience, you would you know, still be able to get a role with a BSc.
Yeah, I want to add that although it's not essential, it's beneficial. So if you have a master, it's gonna help you much more on competing with the others, basically, to get that position. And many positions also requires master nowadays. So it's getting more and more common to have a master. So basically, I agree with Emily, it's not essential and you can start with your bachelor, but I would recommend at some point to do a master as well, because in the future it's gonna help you.
It would also help with chartership. So if you're looking at Geological Society chartership masters, if you don't have a kind of fully geoscience undergrad degree, having that masters will help you kind of access chartership, I think a little bit earlier as well. And similarly, if you're looking at jumping across the water to the Institution of Civil Engineers, having a master's education is also beneficial. And that was, you know, one of the reasons why I was also doing my part-time masters. So yes, for job roles and also kind of professional chartership progression.
Looks like there's one more question in the chat box, and we've got 5 minutes left. So it says, what is your advice to geoscientists who want to develop more technical computal data skills? There are plenty of online courses, but if you don't use the skills you learn, I find that they're quite quickly forgotten. If all of you could have a go answering that, kind of a quick fire round, if you like.
That's so I think there's I'm not sure obviously if this individual is a student or is already kind of working in the field. There's quite a few software packages that will give you a free trial, you know, for a short time period. That could be quite nice to figure out, I guess, what your strong points are, or, you know, what might need a bit more work. I don't do any sort of coding, for example, so I use a lot of the kind of pre-issued packages that are quite self-explanatory. And I do agree, yes, it's all well and good doing a course and watching a video, but sometimes, yeah, that doesn't sink in. So maybe doing some more tutorials, that could be quite good.
Yeah, I would add that you need to take a project from wherever you want, like Kaggle competitions, although it's not geo-related, where you can apply those skills. Doesn't matter if it's medical imaging or it's house pricing or financial, it's just to develop your technical skills and data. So at the end, every data skill you get, you can apply to other field with some, I mean, there are differences between geodata and medical imaging, but at the end, many ideas also that are applied to geodata or to medical imaging, for example, come from another field. So don't be only looking at your own field. You need to open your view and take from other places, but just computational or data skills, take a project that you like to work on and follow tutorials, or just ask things to the data. So play with the APIs that the packages have and just play on your own free time.
Yeah, I mean, I don't think I have much to add. I think they both covered. I think it is very easy to sit down, go through a module, an online module, but then if you don't use the skills, you can forget very, very quickly. So there are a lot of hackathons that happen even online, especially throughout the pandemic. There have been a lot of online hackathons that you could participate to. The one thing that one need to be careful with, I mean, it depends very much what kind of technical abilities you want to acquire, what level you want to apply them, in the sense that, for instance, if you want to start using R or Python to do some data analysis, you can do it, and a lot of people do it, and they use more of a cookbook approach. So take some code which is there and try to apply it to your data. But that can also be quite dangerous. So if you do want to, you know, learn some skills that you want to use it extensively in your future job, maybe getting a master and getting into a program that can sort of like start from the foundations, teach you the basics, and then move on. That could also be an option. I'm not saying that just because we have a master's in GIS. I mean, just generally, I think it's, you know, I think you need to make a distinction between whether you want to, again, learn something quickly to do one project, or whether you want to lay the foundations to build something for a long term, I guess.
Thank you. Yeah, that's great. So we've got 1 minute. So it's a fast question. How reliable is the information from WebGIS like OpenStreetMap? So I think that's what everyone wants to know.
I can probably say that, well, what I'm going to say is that there is an entire feeder, a number of research and research groups throughout the world that basically do research only on that, or very much on that. Generally speaking, is quite reliable, especially in Europe. So it's, you know, especially in Europe and in very sort of like central areas. If you take London, I think it's pretty reliable. It will never be complete. I'm not even sure what complete means, but generally, if you look at OpenStreetMap, it's pretty reliable.
Thank you. So I'm going to wrap up this session now. So thank you so much, Emily, Alexandra, and Steph. It's been a really interesting session. I've certainly learned a lot. So next we'll be jumping into a session on Chartership with the Geological Society's Chartership Officer, Sean Richardson, and Holly Fisher from Atkins, who has recently undergone the Chartership process. So Holly and Sean, are you there?
Hello.
Hi.
Hello, me. I'm here as well.
Yeah, I can hear and see now. Great. So thank you for coming along today. Firstly, I think Sean's going to briefly give you an overview of Chartership, the benefits of being chartered and so on. And then Holly's going to kind of talk a bit about her journey to getting chartered. So are you ready, Sean?
Yes, I am, yes. Let me just share the screen.
Great.
I'm just a very good start, is it?
Yeah, no worries.
Right, I think this is it.
Oh, I can see it now.
Right, just one slideshow. Apologies for this, just disappeared again.
It's okay. So along the bottom.
No.
Holly, would you like to go first while Sean finds it in the background, perhaps? Does that be okay, Sean? Or have you got
It's on my, oh, it's here we are. No.
Okay. Sorry, Holly, false alarm.
Okay, just go to slideshow. Right, can everyone see that?
Yeah, that's great.
Okay, thanks. Right, hello everyone. My name is Sean Richardson. I'm the Chartership Officer at the Geological Society of London. My role is to encourage people to become chartered and to take them through the journey and through to an interview stage and hopefully be elected as chartered geologist or chartered scientist. I don't know how many people are in the audience are at the stage where they could apply or whether they're still leaving university, in which case it may be premature, but at least you'll understand the process for the future. Bit of a personal introduction. I hold geoscience degrees at BSc from Leeds, MSc from the Royal School of Mines in London, and also an MBA from Liverpool. I've worked around the world as a petroleum geologist in my main career. I'm now semi-retired and working for GSL. I'm also a chartered geologist and a chartered scientist, so you know, it makes me eminently qualified to do this role. My aims are to introduce a concept of becoming chartered once you embarked on your working career, explain the key components of the chartership application without going into too much detail at this stage, and then just discuss the first steps on your chartership journey. There are things you can do now, even if you are not ready to become chartered, or even if you are still pre-career. And then a slide where you can actually use to find further information. So let's start with chartership. What is chartership? Well, chartership is a professional qualification, and that demonstrates that the person is experienced to work alone and is competent in their chosen field. This is in contrast to academic qualifications, which demonstrate knowledge and understanding of a subject, but not competence. So there is a major distinction there, which you'll find. And competence comes from, you know, basically work experience in a chosen field, and that's an important word there, chosen. You know, because you have to choose a speciality. So the importance of the chartership, well, it's obviously an important career milestone. You need to have at least 4 or 5 years of work experience before you can apply. And that's really so that you can build up the experience and you can acquire the knowledge to justify competence in whatever you're applying for. It indicates a professional practitioner who has been peer assessed and demonstrates key professional competencies in their field of practice. So first of all, you nominate your field of practice, and then you have to demonstrate how you've obtained different professional competencies, and you do that through an interview and 2 scrutineers who review your application. So that's where the peer assessment comes in. The other important thing is looking into the future. It's already becoming a legal and regulatory requirement for signing off reports and providing professional consultation, and I think that will only become more and more important as we move forward in future years. So, chartership with Geological Society of London, we directly award 2 charterships. The first is chartered geologist with the nominal CGEOL behind your name. This is awarded directly following the Royal Charter, which was awarded by King George IV in 1825 to the Society. This chartership is obviously best suited to those with a geoscience background. The second chartership is Chartered Scientist, CSci, and that is awarded by GSL under a license from the Science Council. This is best suited for those who either have a strong science background or do not work in with geoscience information. And it's also possible to attain both of those. I mean, I have both charterships, and we have a streamlined process to allow candidates to acquire the second chartership. So without going into too much detail, there's a number of key components within a chartership application. Besides the general routine work information that you provide on personal information, training, and your education and also your work history, you need to submit a professional report. That's really an enhanced CV in chronological order, but the point is that you have to explain how you've acquired the competencies over time within this professional report. There is also a separate competency overview where you give a bit more detail about the key competency criteria. And for chartered geologists, we have 7 criteria. And for chartered scientists, we have 5 criteria. So you have to go through each of those and explain briefly, you know, what your evidence is for those criteria. CPD, this is always a bone of contention. CPD is continuing professional development. So all candidates must submit 3 years worth of records. The key thing about this is they are developmental activities. So you're obviously learning something from CPD. And this is a lifelong sort of journey you do. Start from basically when you leave university, I would suggest, and continue it through to retirement. You know, you're always going to be able to learn something. And if you become chartered, you have to continue to do CPD every year. And quite often you may be asked to supply those records for checking. The other key part of an application are the supporting documents, and you supply up to 6 supporting documents. And these are based on your work experience, work projects, or other activities. And the key part of this is that they should demonstrate meeting the 7 criteria or 5 criteria, and you know, with detailed evidence, so that the scrutineers will read these and basically assess your competency of meeting those criteria. And then finally, you'll need chartered sponsor statement. We used to ask for 2, but now we're just asking for 1 going forward. And they basically attest to your fitness to become a chartered geologist or chartered scientist. And then if all goes well, the scrutineers agree with your application, you will be invited to attend an interview. Following that, a recommendation will be made, and the candidate will be elected by the GovSoc Council. I don't expect you to read this in detail. This is something just to show that these are the 7 criteria for chartered geologists. The 2 key ones for the geoscientists among you are these first 2, understanding complexity of geology in space and time. And the second one is critical evaluation of geoscience information to generate predictive models. These are particular to the CGEOL chartership. We have other ones for charter scientists. And then we have the other competency criteria which you will have to meet. So, for instance, you know, management of HSC is clearly something you can't do without work experience. So that, you know, sort of limits your ability to apply too early on. So bear in mind that, you know, if you are leaving university, start thinking about maybe, you know, 4 or 5 years time applying for chartership, and start building a CPD record now, and think about potential projects you can work on over time. For chartered scientists, we have different competency criteria, but they cover the same range of skills essentially. Application and knowledge and understanding here is really combined competency criteria 1 and 2 for the chartered geologist. But, you know, personal responsibility, interpersonal skills, professional practice, professionally, these are all more or less the same, just different wording around them. So first steps I would recommend, anyone who is vaguely interested in chartership, the first thing is to join the Geological Society as a fellow. This is essential if chartership is a consideration. You're not allowed to apply without that. And then start recording CPD as soon as you can. You know, clearly we need 3 years of CPD for a chartership application, but I think, you know, the earlier you start, the better. There's lots of advice on the website how to do this, and you know, perhaps link them with your company targets and development targets. You know, more chance then that you will actually fulfill those actions. And then once you find work, I would suggest that you find a sponsor, a mentor, and start working jointly, and start thinking about projects which should help you build competency for those supporting documents. And through time, then, you know, you start thinking about who could be your sponsor. It could even be your mentor who's worked with you for a number of years. that's really all I have to say on Chartership. I know it's brief, but if you have any questions or want further information, please, by all means, free to use this email address for Chartership, geoscience.org.uk, and look on the website for further information. And then, if you read that and you still have questions, then, email into Chartership for more specific answers. All right, thank you very much for listening. I don't know if there's any questions now, or we're going to wait till after Holly's going to talk.
I think we'll jump straight into Holly's and then tackle the questions after, if that's okay with you both.
Yeah.
Great. Well, thanks, Sean. That was really useful. I'm sure kind of Chartership is a long-term thing that students are probably thinking about. So, Holly, oh yeah, I can see your presentation. Great.
You see it on the big screen?
I can, yeah.
Okay, good. So, cool. Hi everybody. Thanks for joining today. My name is Holly. I'm an engineering or chartered engineering geologist with a company called Atkins. Atkins are a engineering consultancy. So in terms of the geosciences, we primarily employ kind of the engineering side. We also have some geomorphologists and GIS specialists, but engineering geologists is where we're we've got the most geoscientists. So I am going to talk to you today about my role within Atkins as an engineering geologist, how I got there, and how I got chartered, essentially. So when I was at school, I loved geography, hated everything else. So I found a course called Physical Geography and Geology at the University of Plymouth and joined it straight away. Left with a good grade, 2-1, and took a year out and went to the Netherlands, where which is where my family are from. And I found there a similar company to Atkins, an engineering consultancy called Royal Haskoning. And I essentially just emailed somebody on LinkedIn and asked for a placement. And I ended up getting a 4-month placement as an engineering geologist there. Did a lot of modelling using rockworks, and just had a great time, and then realised that actually this is what I'd like to be doing as my career. So then I went to the University of Portsmouth and did an MSc in engineering geology. And I was really lucky that straight off the back of that, I got a job at Atkins as a graduate engineering geologist. This is within our ground engineering and tunnelling department. So I've been with Atkins now for 7 years, and last year I got chartered. So that's kind of my where I am now. So what is my job? Well, as I've said several times, I am an engineering geologist, and my time is split between site work and office work. So if you don't know what an engineering geologist is, we essentially look at the ground for engineering projects. We study the ground, we provide engineering parameters for design of embankments, cuttings, different types of foundations, and we do this for basically everything that you can think of. So pipelines, roads, buildings, railways, bridges, offshore wind farms, etc., etc. So my most favourite part of the project is the site work. I've been lucky that I've travelled all across the UK. Typically I'm in the southeast of England, in around kind of London and the rest of the southeast, because that's where my office is. But I've also managed to travel up to Scotland. I was just up in Edinburgh last week, and also lucky have been abroad a few times. And the picture in the corner there is of a ground investigation in Sierra Leone. So most of the site work is related to ground investigation, getting that information of the ground and so specifying it, getting that information of the ground, interpreting it and providing then to our designers the parameters and the information that they will need then for design, and sometimes do a little bit of the preliminary design ourselves as well. Often as well, we get to do some construction supervision, which is a little bit different to some other kind of geoscience roles. So we actually get to be there when, for instance, the two pictures in the middle, there's a shaft being constructed for a tunnel, and there's also a sheet pile wall being constructed in the dam of a reservoir. And as part of that, we would make sure that the ground conditions are as expected and provide recommendations if, if anything was different to what we were already expecting. So in terms of the site work, my role has changed slightly as I've progressed, as I've become more competent as an engineering geologist. Initially, I'd be out on site, kind of sat with the contractors, learning, logging, and just gathering all of that information. Eventually, I've gone into more of a supervisory role. This is what we want, this is where we want it. Is it being undertaken in a way that will provide us with enough information for the design? And then eventually I've been doing this kind of construction supervision. Is everything to plan? Does it meet our design requirements? And all of that comes with understanding what you're doing and being competent within it, which is a key criteria, or the only criteria for chartership. So the other half of my job is in the office, and I've been doing a lot of this past 18 months, as I'm sure everybody else is. But essentially, we are taking all the different bits of information. So initially, it will be what's called desk-based studies, and this is where you get all the freely available information, the fantastic logs and maps from the BGS, and you put it all in one place, and you find out what the ground conditions are at your site. You may have some gaps in that data, in which case you'd specify the ground investigation. And then once you've done the ground investigation, you gather all of that preliminary information, all of this new information, and you create your models. 3D models, cross sections, maps. It comes in plenty of different forms. Sometimes they're hand drawn, sometimes we use CAD, sometimes it's GIS, but they all have the same purpose, and to provide our designers with a good detailed level of information for them to then do their design. We also, obviously, because it's engineering, gather all the geotechnical data to provide parameters that will get used for design. So how strong is the ground? How stiff is it? And again, my kind of role as I have become more competent has changed. I've gone from kind of being told what to do and doing the desk-based studies to leading and checking our more detailed interpretive reports. I've gone from working on smaller projects to larger, more sensitive projects. So I work on a huge variety of projects. Currently, I'm working on something called Havant Thicket Reservoir. This is the first reservoir to be built in the UK in over 30 years. It's a huge feat of engineering, and it's currently up for a few awards. And I've been included within this based on my past experience in water projects. I showed that I was competent as an engineering geologist in water-based projects, and so I was asked to be a part of this quite prestigious project. I'm also working on offshore wind farms. This is my reason for going up to Scotland last week. And And previously, I have worked on, as I say, a huge variety of engineering-based projects, railways, highways, landslides, nuclear power stations, the less glamorous sewage treatment works, but also one of my most favourite projects was a water supply project in Freetown in Sierra Leone. And this was to provide cleaner and more water to the capital city there. And I managed to go out on site for that as well. So it's not just your technical ability that counts. Being active within the kind of extracurricular activities is hugely important. It makes you stand out. It is the reason why in 2019 I won the early careers the Grand Engineering Young Geoscientist competition. And I am heavily involved with so STEM, so outreach, teaching geosciences to students across the UK of different levels and abilities. As part of that, I run our work experience programme within Atkins, our Grand Engineering team. I've done a lot of careers. You might have seen me at different events across the GSL and within your universities. I'm also a big part of a charity called Diversity in Geoscience. But also probably the most crucial for Chartership is that I'm heavily involved with the Geological Society. So I am chair of the Southeast Regional Group of the Geological Society, and as part of that I attend kind of bi-monthly meetings with other members of the community. I'm running the presentations and making myself more visible, but I'm also making myself aware of how the society runs and its kind of ethical standards. So in terms of Chartership, obviously Sean has gone through the process, so I won't go into that in too much detail. But as a student, CPD is probably the most important thing that you can kind of get your head around now for Chartership. Get involved with those extracurricular activities. Not all of them have to be really obvious, have really obvious geoscience kind of relationships, but start getting involved with different charities, different groups. The GSL, there's a whole early careers network. Get work experience if you can. Try different things. Do you know what kind of geologist you are? That's one of the biggest questions that you have to answer during your chartership application, because that's what you're going to be judged on. What kind of geologist are you? As an engineering geologist, it was a hard question to answer because it's such a broad spectrum. I could be more of a geotechnical engineer, I could be more of a geomorphologist, I could be nice in the middle where I am now, and I focus on ground investigation and characterization. But you're now at the early stages of your careers, you can try different things and get to know what kind of geologist you are. Keep a record. That's probably the best bit of advice, because actually that's probably the most time-consuming part of the whole process. And shout about your achievements. If you're doing something different, tell people on LinkedIn, apply for different awards, get your name out there and known. And when you're looking at getting a career, joining a company, ask the question, does your company have a mentoring scheme? And is it a good one? Because the support is probably it's probably the reason I got chartered in the first place. It's a long process and you really do need that support. And kind of lastly, just remember this is a qualification. It doesn't always go to plan. I didn't pass first time. Took me a couple of goes, but now I am a chartered engineering geologist and I'm proud of it. And why is it worth it? Well, of course, there's the promotion and the money that comes with it. Your company can sell that you are a chartered professional. so they can charge more, so therefore you get paid more. Your role will change. You have shown that you're competent as a geologist, but also, and this is the thing that I did it for, is the personal achievement. You could be proud of what you've done. So I am on LinkedIn. I run the South East Regional Group LinkedIn page, as well as our Atkins Ground Engineering tunneling page. I'm also got my own account, so please do drop me a message if you've got any questions. Always happy to help. And that's me.
Thanks, Holly. That was brilliant. And thanks to Sean. We have had some questions come in. So the first one, can experience and skills learnt during a PhD be used as CPD evidence?
For me, yes, I see no reason why you can't use PhD activity and project work to for CPD, but that's not the same as actually basically competency, for a chartership interview. I mean, CPD is about any developmental learning, and you should be doing that all the time as soon as you can start from BSc onwards, I would suggest. It's an interesting point about, I do actually tend to get a lot of queries and questions about, I'm doing a PhD, can I use that for evidence of, supporting documents in the chartership application? I would suggest you could use maybe part of it, but not all of it. It has to be based on work experience and real world data. There's certain competencies that you probably can't acquire just doing a university course.
Great, thanks, Sean. That's a good answer. So I've got another question. I'll ask Holly first, because you've recently gone through the process. Would you say it's easier to get chartership at a big company such as Atkins, or easier to get chartership at smaller companies, or is it hard to kind of say?
I think it would, obviously I've only worked for a large company, but I would say it is fully dependent on the company and how focused they are on mentoring and supporting you through chartership. We're very lucky that as a big company, there's lots of people that I could go to for advice. We've got hundreds of geologists. So finding the person that was right for me was easy, because there was somebody that had already done something very similar to what I was going through. And I'm not sure if you would have that at a smaller company, but if they have an external network, then there's no reason why they can't be just as good.
Thanks, Holly. Sean, do you have an opinion on this either way, big companies versus small companies?
To be honest, it shouldn't really make any difference, provided you can find a decent sponsor or a mentor to guide you. The key thing is actually gaining the experience through project work. Sometimes if you work in a large company, you get pigeonholed into one area, and it's difficult to actually expand your skill sets. If you work for a small company, you're a jack of all trades, and you have to get involved in a lot more different things. Conversely, I find that sometimes people who work on very small companies, especially overseas, working in mining companies in Africa, etc., they find it very difficult to apply because they don't know anybody who can sponsor them. Whereas in a company like Atkins, we get multiple applications every time there's an interview round. Same with a lot of other big engineering companies. So, it's not an easy, there's not just one answer. There's a whole range of things. But at the end of the day, you should be looking at job satisfaction within your company, because you're going to spend a lot of time working your career. So, there's means and ways to become chartered regardless of which type of company you're working in.
Super, thanks. So we've got a couple more questions. Can a petroleum geologist apply to get chartership?
Well, I'm a petroleum geologist by background, and I've been chartered since about 1992. So yes, we get a lot of petroleum geologists applying, less so than maybe in engineering geology. And that's for probably cultural reasons, as much as that, in terms of management requirements. But they've got the skill sets, and there are an awful lot of petroleum geologists who are chartered with the Geological Society and are also scrutineers as well.
Fantastic, thank you. So there's another question which I think is probably going to be a short answer. Can a geologist acquire both CGEOL and CSCI?
Yes, I think I answered that in my presentation. You can do both, yes, but it's better to do one and then the other rather than both at the same time.
Super.
Choose your strongest one first.
Okay. Is a master's degree compulsory for getting a chartership qualification? Sorry about the dog.
I would say no, but you have to demonstrate working to master's level. So for those who left university and started work before they thought about it, they have to supply what we call a master's equivalence report instead of having an MSc. And that is a short report covering a particular project they wish to write about. But the key thing is critical thinking. Master's levels are all about critical thinking rather than being taught a subject. So that's the purpose of that report, to bring out critical thinking.
Thanks, Sean. I'm just having a little look now. Can experience and skills, oh no, I've done that one. Oh, someone's asked for your email address, Sean, so could you pop that in the chat box?
Well, you've got it, so can you just pass it on?
Okay, yep.
If you don't mind.
And then there's another question. Is there a stage after chartership to prove even more competency in the field? So I'm assuming that's some kind of post-chartership qualification or advanced chartership qualification? Is there such thing?
Well, there's not really qualification, but there are other routes after being chartered, but they're mainly in the sort of the contaminated land and engineering side. You could become a Eurogeologist, which doesn't really demonstrate any additional skills, but it's really an add-on to, you have to become chartered to do that. And then there's other ones called, like GOGEP and SILK, which are, again, professional qualifications, which require another exam to be done. But again, they're in the sort of engineering and contaminated land fields. So in terms of hydrogeology, mining, oil and gas, and a lot of the other environmental science, there's very few extra qualifications you can go for, but maybe a chartered scientist is a good add-on to a chartered geologist qualification.
So Holly, can I ask you a question next? What are the first steps that you took to become chartered?
So within Atkins, we're really lucky. We've got such a structured kind of process that the first thing is to make sure is to get a mentor. And I got that within the first few weeks of joining. And then it's essentially as the first kind of year or two, you'll be finding your feet as a geologist, as whatever you're doing. And then it's then kind of picking out where you may have gaps in order to fulfill those competencies, and then making sure that you're familiar with your mentor, with your line manager, with whoever, in order to get those gaps filled. So the first steps would be to get yourself a mentor, have regular meetings with them, and then work out where your gaps are.
Thanks, Holly. That's really helpful. I've got another question. Can you specify on the eligibility of geologists, brackets, geographical location / nationality that qualifies for a membership fellowship in the GSL? So I guess that's a question for me as well as Sean, but Sean, do you want to start?
Yeah, we do not discriminate against people regardless of their geography or location. The first thing, they have to be a member, a fellow of the Geological Society, though that's a mandatory step, and anyone can join. And after that, it's all down to the basically their competencies. You know, when they feel they're ready, do they have a mentor or a sponsor? They certainly need a sponsor. They don't necessarily need a mentor, but it certainly is advisable. But you know, I tend to get people applying from overseas on a regular basis. You know, we've had people applying from India, China, Hong Kong, Australia, New Zealand, where else? Peru, and in the different parts of the Caribbean, Canada. You know, certainly lots of different places in Africa. Even Kazakhstan, I've had someone apply, and you know, it's not a problem. But they just have to meet the regulations in terms of being an FGS and then having a sponsor and being competent and meet the competencies.
Thanks, Sean. That's great. I don't think I really have anything to add to that. So Holly, another question for you. Since becoming chartered, has your role changed? Do you have more responsibility and do you get to work on more significant projects?
Yes, definitely. So my role has changed quite a bit. I'm managing my own projects. I've got my own team, and I am working on, as I say, quite prestigious projects, some of which I can't talk about, and leading those as well. So whereas before you'd be doing all the originating, you'd have quite a low responsibility. Now it's yeah, very stressful, but is worth it. I'm getting to go to more exciting places, and yeah, definitely.
Thanks, Holly. That's great. So another thing is maintaining chartership status. So could you talk a little bit about kind of the continued professional development side of things?
Yes, it's regulations stipulate that once you become a chartered geologist or chartered scientist, you must maintain your CPD records every year. The Geological Society audit about 5%, 6% of the members to confirm that they are actually meeting the minimum number of hours of CPD. You know, there's a huge range of activities that qualify for CPD. I would recommend anybody looks at the Geological Society website and look up the what we call the mind map, which is a bit like an octopus tentacles, but it's got all the activities and categories. So it's not about going on training courses. That's part of it, but there's lots of other activities which are developing you as a professional, which count. And if you're in full-time employment, you need to record 90 hours, a minimum of 90 hours per year. And if you're working part-time, then you record 50 hours per annum. But that's a lifelong sort of thing. Provided you hold a chartership, you must do CPD. You can do it online on the Geological Society website. You can log it directly online, or you can log it on an Excel spreadsheet template that we can also provide, or even your own company format if you need to. But I would recommend that anybody who's working with a company who do target setting at the end of the year, or the the year you've just gone, or you do developmental planning, try to align your targets, company targets, with your CPD targets, and there's more chance of you meeting those targets that way.
Just as well, 90 hours seems a lot, and it seems a bit daunting, but a big chunk of that will come from working on the job. working on different projects in different ground conditions, different types of projects where you have to do the research, and also being involved with some of the more extracurricular activities, like I've said in my presentation, makes it very easy to help bump up those hours as well.
Yeah, well, I mean, 90 hours is less than 2 hours a week, so you know, it's not too onerous, to be honest. I think most people do CPD without realizing it as well. You know, there's this mindset that you must go on a training course to qualify for CPD, but there's, you know, there's a host of different things you can do, even reading a journal in the office, or, you know, basically holding a meeting to discuss a new opportunity, and, you know, what skills you need and how you're going to staff it. Going to HSE meetings and discussing issues, those are all CPD activities. Going to a regional geological society presentation, that's also CPD.
Thanks. Yeah, I absolutely agree. There's a lot of activity that students and obviously graduates can get involved in at the Geological Society. Feel free to kind of contact me after this event, and I can kind of point you in the right direction of various resources. Holly has also involved in various different things. So I'm sure, Holly, you'd be able to point students in the right direction of things to kind of get involved in.
Yeah, definitely.
So that brings us to the end of this session. So thank you ever so much to Sean and Holly. It's very useful. I've put Sean's email address in the Q&A box, but I'll also add it to the chat as well. But you'll be able to find details on the Society's webpage or further details about Chartership. But don't hesitate to get in touch if you need further information. Thank you both very much to you. And we're about to take a kind of short break for 15 minutes, and then we'll be back at 4:15 with a session on transferable skills. So thanks everyone, and we'll see you in about 15 minutes.
Thank you.
Thank you.
Hi everyone, welcome back. It's the final session of the day now. It's a session on transferable skills, and we've got a great panel. So we've got Lucy Thomas, we've got Serdar Aldermanzala, sorry if I mispronounced that. We've got Lorraine O'Leary, and Chris Swainston should be joining us shortly. So Lucy, would you like to start?
Sure, I shall just share my screen.
Super.
Okay, can everybody see that?
Yep.
Excellent. Okay, so welcome to the, I guess, one of the later afternoon sessions today. My name's Lucy Thomas, and I'm the Chief Scientist and Managing Director of our operations in Africa, and I work at RSK Group Limited. So a little bit about me. I had no idea what I wanted to do. Initially, I looked at travel and tourism and tropical environmental science at Aberdeen University. What I did know is I didn't want to be in an office all the time, and I really enjoyed being outdoors. So that sort of led me down the physical geography, geology type route. I also really wanted to make a difference in the world. I wasn't sure what that difference was, but I knew I wanted to make one. In the end, I studied applied environmental geology at Portsmouth, which was a brilliant course with loads of field work and skills that I apply today, even though I graduated a long time ago, some might say, in 1998. Certainly the world was a bit different then. Mobile phones were not as commonplace as they are now in particular. So, and then 20 years later, you might say things have gone full circle. Or at least before the pandemic. I spend far too much time now staring at a computer. But before the pandemic, I was traveling across Europe, Africa, and the Middle East, speaking at conferences, representing industry on various external committees, helping change regulatory guidance. And we also established and managed, as I still do, our African businesses. But it was a lot more fun when I could travel and see the teams in the real world, if you like. So the picture on the right is a picture of Kilimanjaro from the aeroplane when I was flying across from Nairobi one day. And then there's a picture of me with some of the team recently at our, well, certainly my first real face-to-face event for a very long time. So that was at some safety awards that we were up for an award at. So what about a typical day for me? They're very, very varied. Every day is different, which is why I really enjoy this job. So sometimes I might be overseeing the removal of underground fuel storage tanks, or doing a safety or technical inspection on the team that are undertaking the works. I could be volunteering at a local school. I could be participating in International Women's Day, which I was in Tanzania for, so that was great fun. So as a director, I do spend quite a bit of time presenting at conferences, engaging with stakeholders, and obviously internal directors developing strategy for our business. So and I was obviously part of my role in terms of managing Africa is helping the Ugandan, Tanzanian and South African teams develop. So they came to a conference with us and manned the stand, so to speak, and also did some speaking with me on the stage as well. As a director, of course, I do spend quite a lot of time looking at spreadsheets, mainly of numbers. So I thought I needed to have a picture of a spreadsheet in there for you as well. And then a photo at the top of Team Tanzania. So that's the one of the more recent big projects that I've worked on. So we were cleaning up petrol filling stations and depots across Tanzania and Uganda at about 30 different sites. And we started off with a team of 0 because we had a new business to set it up. and had a team of 100 within about 6 to 9 months delivering the project. So yeah, it was quite busy, but great fun as well. So how did I suppose, work my way through from being a graduate through to a director over the last 22 years or so? I think I came out of university at quite a good time. Land contamination was quite a new topic. It was emerging and it was becoming mainstream as the legislation had come out. And I was quite fortunate because I had a strong grounding in geotechnical and land contamination. And at the time, sometimes in some of the businesses, the two sort of disciplines, if you like, didn't always work in parallel. So quite often in some of my early roles, I was purposefully encouraged to, get the two teams to talk to each other, understand the differences between the disciplines and how they could actually support each other rather than end up competing for work, which doesn't really help anyone. I guess a similar thing today might be sustainability, carbon measurement, renewable energy. So, there's always something new as we all develop that, is the new thing to go into. I also capitalised on human health and groundwater risk assessment because that was in its infancy. And I was lucky enough to go on one of the early courses and then ultimately became chair of the Society of Brownfield Risk Assessment. So yeah, that was quite a good route through, if you like, and training others, and also the NHBC on some of the risk assessment programs that we use. I'd also really emphasize good mentors are key. So, be honest with yourself, find out what you're not so good at or what doesn't come naturally. Find someone in your organization that's really good and either copy them or ask them to be your mentor sort of more officially, and they will almost certainly say yes. Lots of problem solving, resilience, teamwork, flexibility, and when you're encouraged to go out of your comfort zone, i.e. go to Africa and run some businesses from scratch, say yes. Also know when to say no though, because otherwise it can get a bit too chaotic. So yeah, I just thought I'd finish with this slide. So geosciences for the future and how they link to the UN Sustainable Development Goals, because geoscience is a really good broad brush subject from which you can go into a lot of different disciplines and really help make a difference and contribute to the UN SDGs. So thank you very much for listening. I think we're going to have questions afterwards. But feel free to put them in the chat in the meantime. And I will pass over to Sadar, if I can work out how to unmute my screen, which is clearly proving problematic. Becky, could you assist?
I've stopped it now.
Yeah, brilliant, thank you.
Thanks, Lucy, that was brilliant. Sadar, are you ready?
Hello, thank you, Lucy. Thank you, Becky. Thank you for having me. Let me just put this moment. Just share my seconds. Go. Okay. Okay. Welcome everyone, and this is going to be my section about transferable skills. My name is Serdar Aldanmazlar. I'm a consultant of ISO systems, which is my focus on is, as you can see here, is quality management, environmental management systems, and occupational health and safety. But my degree is in geological engineering. But I will try to give some idea about what I actually do, and why it counts as a transferable skill. So let's move on. Okay, a little bit about my background. As I said, I'm a graduate of Ankara University from Turkey, from geological engineering. I'm a fellow of London Geological Society, and this one is MCQP, which means Chartered Quality Professional, which you have to sort of have to work in the UK as a quality professional. It helps. It's not a requirement, but it's quite helpful, which we'll come back to that. Currently, I'm employed as an ISO management systems consultant, and also I'm self-employed. So majority of my experience is going to be self-employed side, but also this can be done as a full-time job as well. Also, you can use the skills in your existing jobs as well. So they are quite flexible and applicable to almost every aspect of whatever industry you choose to work. Okay, moving on. So I'm pretty sure everyone saw these two logos in somewhere. Anything you use, anything that is produced these days, if they are high quality, they will have these logos one way or another. You must come across to them, or maybe this is mentioned somewhere. So what are they? What is ISO? ISO is a European organization based in Switzerland, aimed to standardize management systems and in general try to establish a framework for all businesses, services, and goods. My specialty is the trifecta. What we call is quality, environmental, occupational health and safety management systems. One point is they are not product and service standards. So this is more on the management and process management side. One advantage is these systems can be used by all organizations or public bodies or any private business. It doesn't matter what they do. If they are manufacturing something or they are providing a service, they can benefit greatly from that. There are many other management systems, information management or energy management, which is quite prevalent these days, but today I'm not going to talk about them. Okay, just what I do as a day-to-day work. Well, I work on the client side mostly. There is a certification side as well. So that's quite different than what I do. The basics is if a company doesn't have a system established, I will help them to establish the systems by observing their processes, whatever they might be, and establish the processes, prepare the paperwork, prepare the flow charts, regardless of the topic. It can be quality, it can be environmental, it can be health and safety. If they have an existing system, I'll support them maintaining this system. I track their key performance indicators, revise the processes if they need to be revised, or conduct internal assessments to see if the system is working or not. Majority of my job is performing regular internal audits, and this is quite the big aspect of the quality management or health and environmental health systems. And also I assist them when a certification from UCAS or British standards is coming. And other than that, I just offer them general advice on how to improve their quality, environmental, health and safety management systems in all broad kind of topics. Okay, so that's pretty much a consultancy job and involves working with large amounts of data and also quite office-based. So if you are considering something on the field, or like open spaces, this might not be the best way to go as a full-time career, but you can have this as a side skill. So how can you become one? So it's actually quite simple. There is a quite structured, since it's a standard, there's a quite structured system to it. Basically, you start with awareness or requirements training, which is usually 1 day. Then you will switch to internal audit training, which takes 2 days. Then you are expected to have some in-job experience doing auditing. Couple of years, 1 or 2, but this is not a really hard requirement. You can straight up go to lead internal auditor training if you have the basics good. This is quite an investment. It's quite a big investment in money and time. but it eventually pays off. It's a quite good career if you want to, if you are how can I put this? If you are outgoing and chase leads, and eventually you might want to apply for CQI Charter or RSA Registered Internal Auditor, which leads to eventually becoming a certification auditor, which works with certification bodies like BSI or UCAS or Bureau Veritas, which is quite a good and flexible job as well. Many people late in their careers opt to that because it doesn't require any kind of too much additional training, and we will come to that later. Okay, how did I get here? How did this start? Well, I graduated as a geological engineer, and my first job was in Northern Africa in construction materials testing and geotechnical laboratory management. Then I have worked for 12 years in the same sector, but in the meantime, my previous company in 2011, they asked me to get the certification to establish this quality management system, and I get the certification. One thing led to another. Now I have pretty much many certifications well beyond this, and I moved to London and established my own limited company. And while I was doing my ISO 9000 work, I expanded into environmental management and health and safety. Okay, how can you become one, and how to find work? You can either choose to be a full-time auditor or work as a contractor. Both are viable options with their pros and cons. Well, for especially full-time, LinkedIn or other job sites are still the way to go. I put some keywords if you want to look into these jobs, how much they pay, what are the terms. And during the interviews, it's especially expected from you to focus on methodical approaches, and especially interpersonal skills are quite important because you will be working with a lot of people. The work can include a lot of traveling, which might be a good thing or which might be a bad thing, depending on how you look at it. Remote working became slightly prevalent during the lockdown, but that's again going back to normal because most of our work involves being on site and observing in real time or talking with a lot of people, which not be easy to do remotely. But it's a mixed hybrid model, which is quite good. Computer literacy helps. You will be dealing with a lot of documentation from and a lot of data. Excel knowledge is quite helpful. And I hope you are not bored with paperwork because there's going to be mountains of paperwork, but eventually you will gain the speed and you'll just go through them quite easily. Report writing and ISO literacy, there's a different language in ISO which you will get used to in time. Report writing skills are quite helpful. That will save a lot of time. And people skills, this is quite important because you will be dealing with a lot of people, from different backgrounds, from CEOs to line workers to middle management. So this is also quite important part of the team. So that's pretty much the basics of this thing. And what I want to emphasize is, before I wrap up, is you can be an internal auditor or quality management systems or environmental health and safety while you are working on your regular job. So it doesn't mean that you have to switch to something. So you might consider having this as a progressive advancement parallel to your existing job. And if you want to reach out to me, you can find my email and my LinkedIn profile here. I would be more than happy to answer any questions you have.
Thanks, Sadar. That's great. Interesting to see the jump that you've made from geotechnical labs to the auditing side as well. Great. Lorraine, I believe you're next. I'll let you share your screen.
I cannot share my screen. Thank you. Sorry, just trying to share my screen. Can everybody see my screen okay?
Yep, that's fine.
Great. Okay, so I'm Lorena Leary. I'm from Fugro, which I understand you've probably heard from quite a lot of people from Fugro today, so apologies for that. But I'm going to talk to you about a slightly different aspect, I suppose. So I myself am a senior engineering geologist in the marine consultancy line of Fugro. So how did it all start for me? Well, I actually went to the University of Liverpool and studied a combined BSc of geology and physical geography. And from that point, I still didn't really know what I wanted to do. So I then went to the University of Bristol and studied a Master's of Research in the Science of Natural Hazards, which you can see on the right-hand side. Got a number of photos from a field trip that we took to kind of look at the impact of hazards on communities, and those particular ones were in Guatemala. So it was all very interesting stuff, but I actually did my project for that on ignimbrites in Italy. So again, a lot of travel involved and a lot of field work involved, but in conjunction with that, I also did a lot of laboratory work, and that sort of led me to Fugro, where I initially started in data acquisition. So with that, there was a lot of offshore on vessels, so not so much on rigs or anything like that, but on vessels, acquiring data, understanding where information was coming from, understanding the soils and the rock conditions that are on site. And from that point, I then utilized all of those skills and moved into the consultancy, still within a marine environment. So everything I do is in an offshore environment. So what is my current role? As I said on the first slide, I am a senior engineering geologist within marine consultancy. A day can comprise of pretty much, as I mentioned, laboratory work, offshore, not so much anymore, but in particular, in my early career, desk-based work, as well as sort of rock core logging, etc. in the lab. I am a chartered geologist and a Eurogeologist. And in addition to that, I'm also a committee member of the engineering group of the Geological Society, something I came to relatively late. I think there's been a lot of talk today about getting involved in that early, and I think that is a sensible suggestion. It widens your network of persons that you encounter. You know, generally once you're in a company, depending on the company you work for, it can become quite insular, I suppose, but by being a member of the engineering group of the Geological Society, it's opened up my network to a much greater group of people, all of whom have an engineering geology background, but perhaps experience that differs from that of my own. It's been very useful and interesting in that aspect. So I guess I've mentioned this a few times, but what type of work do I do on a day-to-day basis? So it's split into three main aspects: the desk-based, laboratory-based, and fieldwork. So the desk-based can range from anything from a geohazard assessment, integration of data, and generation of 3D and 2D ground models, which are very important as part of your demonstration of yourself as a geologist. I think that's one of the aspects that was talked about in the Chartership. In the lab, we often are looking at core logging and microscopy. And then, as I say, finally field work as well, which will be on vessels like those that are demonstrated on the right-hand side. So a big component of my day-to-day is about integrating different types of data. So it's having a broad understanding of different types of information. So this is just a kind of general map to show how the work that I do has opened up opportunities for travel, but also projects in very different parts of the world. So those that are in yellow are locations where I've worked on different projects. And those that are in blue are those that I've actually had the opportunity to travel to, which has been very interesting, actually getting into the field and seeing the different types of geology that are characteristic of these areas. And the good thing about the travel, but also the wide variety of projects, locations, is that it's highlighted the kind of transferability of the skills that I'm developing and continue to develop in my career. So yeah, it's been really useful in that sense. So what skills have been useful? So there's a lot of, I'll come on to some soft skills, but there's a number of kind of technical skills, I suppose, all of which have probably been talked to or will be talked to you about over the next couple of days, including writing skills, so publishing in journals and conference proceedings has been a predominant part of the work that I do, sharing those lessons learned, both technically and soft skills. GIS and the use of GIS and our understanding of how those databases are built, and also utilizing GIS as a tool to facilitate the development of the ground models that I talked about, and actually making your life as a geologist easier by using the available sort of technology that's there. But I think a key skill that I have continued to utilize throughout my career is this principle of observation, which is one of the kind of grounding informations I remember from my geology course. My geology degree was making observations and from those making interpretations. And that continues to be a key element of my everyday work. And it's been really important in ensuring that you have a sound basis for any interpretations that you make. And here's just a nice colorful word cloud to just demonstrate some of the softer sort of skills that have been and are increasingly important in my career, but also what we tend to look for in those coming in to new job roles. And I think the big one in the middle of enthusiasm, passion for learning are really important. You know, at no point should we stop being interested in what we do, because we spend a lot of time at work and therefore we want to enjoy it. But things like teamwork is so important. You know, for myself, having worked on site, having that teamwork element and those interpersonal skills to get along with people is it's vital. To again, coming back to the ensuring that you're enjoying your everyday work. And then it's just the communication skills and writing skills, you know, those being able to put across the observations and your learnings to others. We do a lot of communication throughout the day in different mediums, and being able to adapt to those is really important for what I do on a day-to-day basis. So very brief there, but if there are any questions, and obviously we've got the panel session coming up, and I will also be, or colleagues of mine will be at the networking session that is on tomorrow, if anybody would like to speak about any of the aspects that you've seen today. And then there's just a bit of information about Fugro itself I'm here representing as well. All right, thank you very much.
Thanks, Lorraine. Love the slide with the enthusiasm too. I agree. Chris, would you like to come up to the stage? Or not? That's great. Thanks, Chris. We can see your screen. I think you need to unmute. Just in the bottom left of the screen.
Hello.
Great. And
yes, I'm
are we able to do a camera?
get the video thing back on at the moment.
That's fine.
But never mind. As long as you can see my screen on there, then that's...
Yeah, we're all good. I'll hand over to you.
So, right. So, Chris Swainson, Principal Environmental Engineer for Soils Limited, did a BSc in Geology at Portsmouth Polytechnic, as it was then. Then went on to do a PGCE, teacher training in Geology, Chemistry and Bioscience at Aberystwyth. Since then, I've become a chartered geologist, Clare QP, and a member of the International Association of Hydrogeologists. Current role is as a principal environmental consultant at Soils Limited with our offices in Winchester, Tadworth and Cornwall. And I advise and communicate with clients, regulators and Soils Limited staff in relation to a wide range of different things, mainly based around site investigation, contaminated land, though waste has certainly become an important aspect in the last few years. Hydrogeology, geology, site monitoring, chemical analysis and testing, and asbestos, and that has a star next to it because whilst I can advise on asbestos as far as our company is concerned for people working in it and ensuring that they're safe doing so, it's not something I'm able to actually give to third parties outside, which you can't do unless you're licensed properly. And every day is different. Every day something different will come in. Every site is unique. And one of my lecturers at Portsmouth said at the beginning of our course that if you're lucky, one of you will become an academic geologist. The rest of you will dig holes in the ground for money for the rest of your lives. And I've certainly been doing that quite happily for over 25 years now. So in terms of current projects we're doing, working for Soils Limited, you will have seen some of the pictures on the previous ones and this picture here about some of the places that I've gone around the UK certainly. And what we've got is the major South of England project we're dealing with at the moment around the A27. And we've got a large marina development in the southwest of England and numerous smaller ongoing projects, most of which will generally be either desk studies, which are PIRs, main investigations, MIRs, monitoring, gas and water, doing risk assessments on those. Remediation method statements, when we find something nasty in the ground, what do we do about it? How do we deal with it? How do we stop it being a potential risk or issue to somebody else? Validation and verification of those remediation methods when they're taken, including gas membrane validation, and training, which I undertake for a lot of the different aspects of things that we do within Soils Limited. And most useful in this role, I think, is the ability to adapt, learn new things, keep up to date on changes in this growing field. And as we've previously heard, one of the best ways to do that is getting involved with the groups that are leading on these items. So I'm a member of the AGS, Contaminated Land Working Group, Geological Society Contaminated Land Group as well. Used to be on the Chartership committee before it was dissolved. Member of SOBRA, basically since it started. Also done stuff with British standards as well, I'll come on to later, and GSL, which is a very useful thing if you can actually get onto it if you're doing anything related to contaminated land, because it's a really, really useful resource to get on with other things. So how did I get to where I am today? Well, largely by accident, to be brutally honest. I did a degree, I did PGCE, did some supply teaching, worked for PGO Young Adventure for a season, and saw a job with Clayton's, Clayton Environmental as they were then, in Southampton in a newspaper. So I went for it, and I had an interview with the next teacher who'd become a consultant himself, and he was aware of what skills I could bring from my PGCE and teaching experience to the consultancy role, because there's quite a lot of useful skills that you can get through teacher training that will actually help you in any other career that you ever want to do. So I started work on the 14th of February, remember that as Valentine's Day, brushing the snow off a borehole to stick a gas monitor on it. And I went through the usual progress of starting essentially a technical role, then becoming an engineer, then becoming a consultant. And I got an awful lot of variety at the time. It was quite unique. I was introduced into lab work, gas risk assessments of that, land, water, ecology, and the whole range of the environmental field that you could go into. Not something that will often happen when you get your first job. It's very, very rare these days. Usually you'll get pigeonholed into something, but we were just generally considered, particularly the younger staff, the more newly qualified staff, as being able to mix and match and move between the various different things as and when demand required us to do so, and also increased our knowledge significantly as well. So I've worked on Prospect Park, the Millennium site. I was involved in Park to A, the first ever Environment Act Park to A investigation and prosecution related to bromide incident in Hatfield. I was also at Buncefield 2 days after they put the fire out, taking samples for the Environment Agency. Did a lot of work for the Environment Agency Thames region, including Harwell and various other nuclear and other sites around the place. Stratford upon Avon, one of those pictures was Shakespeare's back garden, which we had to dig up at one point to try and put an extension on his granddaughter's house next door, which is a museum. Also worked in Warminster on a particularly tricky project for a year where we were trying to clear a former waste site of all the waste that had been left there when the site went bankrupt. As I was at Clayton's, we became part of Law Laboratories, then Casella Stanger, Bureau Veritas, which you've heard previously mentioned in relation to ISO 9001 by the previous speaker. I left in 2006 to join Geotechnics in Coventry at the senior level, where I became a principal in 2009. Geotechnics, I became more involved in the Geological Society of the West Midlands, the AGS Contaminated Land Working Group, British Standards, EH4 Soil Quality, of which I became chair in 2011, became chartered in 2009, and for Geotechnics, established then led on ISO 14001 and 9001 as the champion, also becoming an auditor and a trainer in those as well. So I've written and presented several guidance documents for AGS, including asbestos for site workers, which has recently been updated this year. Also numerous things on sampling, monitoring and British standards as well. Ultimately, I suppose I'm responsible for BS 10175, which is the standard guidance for how to undertake investigations on potentially contaminated land. And as I say, I've been a member of SOBRA since the start of it as well. And then I moved to join Soils Limited as principal in 2018, based in Winchester. So what transferable skills do you get from all of this? Well, one of the things your PGCE will certainly teach you is communication, presentation, organisation, administration and delegation in arguably one of the hardest working areas that you will ever be in. Because if you can't do all of those, teaching is going to kill you, basically. So it is a colloquial way of getting those skills, but it is an exceptionally good one to get them. Once you've been able to talk to 28 hormone bursting school kids who really don't want to be there and actually teach them something, nothing will faze you after that. So the communication skills, certainly talking to clients, regulators, managers and staff. Again, as was previously stated in the ISO presentation, the auditing presentation, you do get to talk to a lot of very different people. And you've got to know what levels of understanding are present at those, be they professional or a client you're working for who may have no background in science or anything related to that at all. Presentation, training clients, fellow professionals, done all of those. There are several things on the Geological Society website that I've done on, including what standards are and how they are. So if you'll have a look out for that, it's on there. Organisation, certainly in terms of site teams, yourself and your own way of dealing with the often more work than you can sensibly do with. Organisational aspects are very, very key to what you're going to be doing most of the time in this sort of business. Administration, that certainly will be learning how to invoice and get people to pay you. Certification, calibration, ISO awareness as well is all part of administration. And delegation, certainly when you get to the higher levels, you will be expected to lead teams, you will be taking management roles, you will be expecting to train other people as well. Personal development, I would say, is another very, very good skill to try and acquire. Changes in practice and understanding as whatever you're in develops and grows. Certainly, as was mentioned earlier, there's an increasing amount of use of technology and things like that, and knowing how and when to apply those in any particular circumstance is very useful. And certainly for your CPD, on your way to chartership or during chartership and after chartership, any of that you can do to learn new things, to join other groups, to help produce standards or provide training, things like that. Because nothing teaches you more about your subject than having to train somebody else about it. Adaptability, that's the one thing that cannot be trained, but it can be learned. And I would suggest that that is probably one of the key transferable skills that you will get whenever you come into an industry like ours, because you have to be adaptable in order to cope with all the changes that will happen as you grow and develop within what you're doing. So in terms of geology, certainly you need definitely an understanding of basic principles, contaminated land and understanding of environmental systems, and the same for hydrogeology, because all of that, along with the chemistry of exposing, modeling and pollution, will all get you to what is the risk of something being somewhere. What is the risk to an identified vulnerable receptor? And you will have to not only express that, present that, but you'll have to write it as well. So you do get professional writing skills. And I have often thought that I really ought to put professional writer down on my passport, because it is pretty much the majority of what I actually do as a physical job. What you've got to do in that writing and reporting is follow the scientific method. Everything must be justified, everything must be logical, everything must be reasonable and sensible as you're going along. Also, a picture paints 1,000 words, so certainly skills in photography will come your way as a result of doing this. You can write everything under the sun, but if you can take a simple picture of it that shows you, yes, this area has got some oil in it, that is often an infinitely better way to do things. And chartership implies or requires, certainly for contaminated land, if you're taking that route through chartered geologist or chartered scientist, requires you to show us competence in pretty much all of the above in order to get your chartership, which I would strongly recommend anybody and everybody does. As a last little thing on the side up here, you might notice this little Paul Nathaniel thing, which he did for a Geological Society presentation a little while ago. And St Leonard's Court, Sandridge, 2002. I was there. I make it into the history of contaminated land, which is not necessarily a transferable skill, but something nice to be able to say. Thank you.
Thanks, Chris. That's great. And some useful things as to what people would get involved with if they choose that particular career route. There's a question for you. Are there undergraduate internships available in your Winchester office?
Yes, usually. We have one with us at the moment who's between second and third year at Portsmouth. We have a lady who's just joined us who has just finished her MSc at Portsmouth as well. We are looking, because we have an interaction with Portsmouth as our local university, to take on at least one graduate every year.
Great. Lorraine, I can see you've got your camera on, so I guess Fugro do internships. Do you want to take the opportunity to tell people about that? And Sadar, if you want to put your camera on as well for the questions, that would be great.
Yeah, we have internships set up specific to different teams, and any of that information can be found on the Fugro Careers website, which I think has been seen on probably multiple presentations. But yeah, otherwise just get in touch with any of us and we can point anyone in the direction of that.
Great, thanks Lorraine. And RSK does as well, just to add into the mix. So does anyone have any other questions? If so, please type them in the Q&A chat or the general chat and we'll pick them up from there. In the meantime, Sadar, what could you tell us, like, what's the favourite bit of your job? Because you've done quite an interesting transition from working in the lab to sort of setting up your own business.
I have to say, with flexibility, I think being able to schedule your own time is just priceless in terms of when you are working in high-paced environment like construction or geotechnical assessments or similar high-paced environments, you eventually became your schedule, sort of. I'm pretty sure everyone, no matter how long in the business they are, they at least had that period of time. Maybe things are getting better, like in the recent times, with this more flexible work options and remote working now becoming prevalent. But I like the flexibility. I like to be able to organize my schedule, and it's quite remote work friendly at this point. And I can just pack my computer somewhere and work a little bit, come back. That's pretty much the main motivation for me. And also self-employment is, well, it has, of course, it has downsides. You have to chase clients. You have to always be up for looking for contracts. And job security is not in terms of like being fully employed, but especially the day rates are quite good for what we do. It's quite satisfactory if you manage to have yourself like a good amount of multiple clients, or maybe one or two big clients that you will work on a contractor basis. It's quite a good amount of income, and also it's sort of future-proof, if that makes any sense, because once you get any certification, they only expire when the standard changes. So, for example, the ISO 9001 quality standard has changed in 2015, and it's not going to change until 2030. So your certification is good for quite a long time this time, and you can easily change into other certifications because they use the same framework. Pretty much, they are the same standard with some extra additional information regarding environmental or health and safety. But once you get I strongly suggest starting with quality, because that's the framework for the rest of them. So that's also good. So it's quite flexible and quite easy to get into, but also requires like a progressive advancement. But otherwise, yeah, flexibility, time management, and being able to do this for quite a long time, regardless of physical or employment status.
Thanks, Sadar. That neatly brings us on to one of the two questions that we've got, which is, well, I'll go with the one that you've just sort of started answering, which is for how can fresh graduates join each of the jobs and master's experience? Chris, do you want to take that first, and then we'll go to Lorraine?
Well, I would say for the first part of that is that what we do in the environmental side, yes, you can do an environmental geology degree at Portsmouth, or you could do the MSc environmental up in Nottingham and things like that. But really, in our job, it is like geology itself. It's fine. You can learn the basics of it fairly easily and fairly quickly. But it's the experience of knowing how to apply that, getting out in the field, seeing the rocks and seeing how it works, and building the models and seeing how it all comes together, is actually probably more important than getting a master or something like that, to be honest. We have a very, very steep learning curve in our industry. That's certainly definitely true. And you can't join every job. The question is to pick and choose the one where they want you and you want to be. I would say put that as your top criteria. What can I learn most from doing whatever I'm going to be doing, and what benefits can I bring to them to convince them to take me. So I would say that is the answer to that one, is pick and choose, and try and find one where there is a compatibility between your goals.
Thanks, Chris. Lorraine, did you want to add anything to that? Or?
Yeah, really to emphasise the agreement with what Chris has said. I think it really depends on what you're interested in. You know, if you want to do a master's because you found something interesting, then I think, you know, do that. It's not going to be any detriment to you. But I think the key thing is that it's not necessarily vital. And we see people, and I have friends who have masters who have done very well, those that have bachelors who have progressed exactly the same progress once they're in the company that they've chosen. So I think it really depends on things beyond a degree as well, you know, very much about these transferable skills that we've all emphasized today, that, you know, be flexible, be adaptable, and be confident, you know, be confident in the skills that you have developed, because they can take you towards what you are interested in.
I guess it's always difficult getting that first job, but once you're through the door, the degree qualifications become less relevant and the experience becomes critical. Okay, the other question is, for people with strong writing skills, what would be a good geoscience career for them? So my thinking was a communications type one, be it in, you know, a communications department of a big company. And the other aspect might be, if you're more interested on the getting involved in the technical side and the project delivery, it could be environmental social impact assessments, because there's a lot of writing with those. And that's where you evaluate the impact of a project on people or the environment. I don't know if anyone else has got anything to add to that.
One thing worth adding is journals. You know, a lot of what we do is published as well, and there's a lot of active geological journals that, you know, that sort of advanced writing skills would be very beneficial in. So there's an alternative consideration as well, and a number of journals, I think, within the Geological Society.
We actually have a presentation on Friday from our publishing house about journals and getting published. So if you'd like to come along to that, that would be fantastic. It's on Friday morning at, no, Friday afternoon, sorry everyone, at 1:45.
One thing I'd like to say about that, of course, is we're all forgetting the obvious ones, which if you've got excellent communication skills, come and write British standards, come and write European standards, come and write ISO standards, because sometimes, because standards are written by generally professionals who are associated with it, is not necessarily people who are excellent communicators. And so sometimes the standards themselves can fall down in a slightly imprecise use of language that can be sometimes misinterpreted. So I would personally, as a chair of a British standards group, say, yes, if you've got excellent communication skills, come and do something for British standards. Please get involved with one of our groups, because those are people we really, really need. Because if we're not writing the standards properly, people certainly can't apply them.
Sounds good. Any other questions? Not in there. Nope. Any other points anyone wants to bring up that come to mind now that we've seen a few questions? We're all good to go and get our dinner. Okay, well, thank you very much to the panelists for giving up their time to prepare the presentations and speak today. And thank you very much to all of you that have attended. I hope you found the day enjoyable, and particularly to those of you that are online at 5 o'clock. That's always a good start. Becky, did you want to wrap up?
Yeah, thank you all very much. That was an excellent session to finish the day on. So thank you for giving up your time on a Wednesday afternoon. Tomorrow we've got a whole host of other subjects to delve into. We've got energy, we've got climate related sessions, we've got a CV session, and we've also got our sponsored networking session. The sponsored networking session is taking place outside of Zoom, and we'll share details of that tomorrow. But I'd encourage as many people as possible to attend the networking session. It won't be recorded, and it's an opportunity to speak to speakers and our sponsors face to face. I know Fugro want to speak to graduates about opportunities, so it'd be fantastic if you could come along. So thank you everyone, and hopefully I'll see you tomorrow at 11:45. So have a good evening, and I'll catch you all tomorrow. Thanks.
Thanks, Becky.